Good evening, everyone. I'm Chris Boydnitsky. I'm the president of the Fort Worth Astronomical Society, and we are doing another virtual star party. This time, though, we are kind of out in the middle of nowhere. I'm actually down here at my cousin's place down in Grandview, Texas. This is about half hour, 40 minutes south of Fort Worth. And the skies here are a lot darker. It's a really pretty sunset right now. But we do have some high clouds. We have some high cirrus. So the moon is visible right now, but it's kind of a little bit hazy. And it's just now getting dark. So I haven't done a setup of the telescope. It still needs to do its thing. I've gotten all the software set up. I've got all the computers set up, so everything is working. It's actually finally working, except for one camera. But it looks like it's okay. What can we do in the meantime? We can go over some of the stuff that we're going to look at today. So first, we're going to look at the moon. Now, the neat thing about it right now is we are about 49% coverage. Right about 50%. Let's call it 50%. And we like to look at the moon before 60% typically. And the reason is it's not as bright. If we're looking at the full moon, you're looking at it at noon, the middle of the day. The problem with that is you don't see any shadows. You don't have any relief. You can't make out dimensions. You can't see how tall the mountains are. Everything is really flat, so you don't get a lot of detail out of it. We want to look at the moon when it's in a crescent phase, or when it's about 60%, maybe 65 to 70%, we can see stuff along the terminator. That's the day-night line, the dividing line there on the moon. And on the terminator, we can see details like the craters. We can see mountains. We can see valleys. We can see the edges of mare. We can see rebound mountains in the middle of craters. We can see rills. We can see uplift areas. We can see cracks. There's a lot of detail that's really visible along the terminator, where we can see those long shadows. We can make out that relief where we can't really see it at any other phase, especially at full. So right now, I'm taking a look at what I've got. And what I've got is, well, let's do this. I'm going to switch over to a different camera. There we go. So right now, you can see we're facing the north from this position, so the telescope is looking to the north. I actually have it configured like I do usually. So we have let's see, where is it? There we go. How much brighter is that? I'm not sure how much brighter that's going to be. So I have a TeleVue 101 apochromatic refractor. The Apo is it's a 4-inch telescope. This has 2 lenses up in front, 2 lenses in the back near where the eyepiece is, and it is called an apochromatic, which means it doesn't have color. A typical lower-end telescope is called a achromat, and that may have 1, usually 2 lenses just in the front. And if you're looking at bright objects, let's say you're looking at Jupiter, you're looking at a bright star, you're looking at the moon, you can see a lot of color on it. So it's an achromat, in which it's supposed to be no color, but in reality there is some. Typically there's like a yellow and a violet fringe. One side it's violet, one side it's yellow. And that's because the glass is separating those colors out as it passes through. And when it reaches your eye, the paths that those 2 colors are coming in on have diverged. So now you see a yellow side and see a violet side. There are filters you can use to take care of that, but we don't want to mess with that. More expensive telescopes have multiple lenses, so we can have a triplet apochromatic telescope, which has 3 lenses in front. This is a Petzval design, so it has 2 in front and 2 in the back for 4 lenses. And this one does not have really any color. It's one of the best telescopes I've ever looked through of this size, so I'm really happy with it. The other telescope is a 8-inch Ritchie Chrétien This is it has two mirrors. I believe they're both hyperbolic in the back and in the front. And this is the same design that the Hubble is based on. So it is a much bigger telescope. It's an 8-inch. It is a f8. So it's a long focal length that lets you really zoom in on the same objects. If you put the same eyepiece in the one on the right that you do on the one on the left on the left will give you a wider field of view. It's a slower telescope at f5.4, and the one on the right is an f8, so it'll give you more zoom, a smaller field of view for that same given eyepiece. So we are pretty much just waiting. There's not a whole lot we can do. I've got to do a little bit more configuration, and we can only really do it at night. So I can almost get it now. Actually, you might be able to. So what I need to do is find Polaris. It's the very first thing we need to do to make sure this works is do what's called a polar alignment. Excuse me. One moment. I think I actually swallowed a mosquito. I don't recommend it. So, just as an FYI, I am here out in the middle of nowhere. There's not much traffic. There are lots of bugs. And I'm trying to see if anyone has any questions, if anyone has any issues going on. Everything looks okay. Hopefully someone's coming in on Facebook. My wife actually texted me saying that the Facebook link didn't work. I tested it and it looked like it was okay. Sorry, dear. I don't know. Don't know what's going on, but I just tested and it looked like it was okay. It looks like it was going to the right page. So, hope everyone sees it just fine. If there are any issues, go ahead and let me know. Let me know if the audio is fine as well. So where was I? So we're going to do a polar alignment. And the first thing I'm going to do is see if I can switch to this. All right, so we're going to switch over. This is my regular laptop for messing around with pretty much everything here. So I'm going to bring up an application called Polemaster. And Polemaster is a nifty little system that lets me... Oh, there we go. Well, so we got some clouds here. And that could be Polaris up there. So I've got to do this. Let's see if we can find... That is not Polaris. It's bright, but it's not Polaris. I'm trying to see if I can see it. There's some cloudiness up there. It's really hard to see, and I actually have a studio light over here that's lighting me up, so y'all can see me. Otherwise, it is pretty dark out here. In terms of like the neighbors, there's a house over there. I don't know if you can see. Yeah, there we go. So there's a house over there which has some lights from a window. And that's it. I really don't see any of the lights. And the house over here, they've got the lights turned out, so it's nice and dark. Okay. Yeah. And for the mosquitoes, I actually do have some DEET spray, so I'm doing okay on the mosquitoes. What are we going to do? We got to find Polaris. So bear with me. Here's what I'm going to do. The Polemaster is a nifty little camera that fits on the front of the telescope, on the mount, and what it lets me do is once I can get Polaris in my field of view, I can go ahead and do the alignment. And the alignment lets me make sure that the mount is pointed directly at the North Celestial Pole. Do it very, very quickly. I just have to find Polaris. Normally what I do is I come out the next day, I came out the previous day. I have all the equipment set up. I do my polar alignment once it gets really dark, and everything is hunky-dory for the next day. I had to come out here this evening and get everything set up in the late afternoon, and I thought everything was okay. I thought I had it roughly set up to north. It's not quite where it should be, so let's figure out what I'm doing wrong. Where would Polaris be? So bear with me. I'm going to switch over to a different camera. I guess this is going to be entertaining. Yeah, we're going to switch over this way so you can kind of see what I'm doing. So we have the one telescope over here, another telescope over here, and the polar masters on the other side of the telescope through here. What I'm going to do, probably get a lav find Polaris. Where is Polaris? There's Polaris. I am way off. Is that Polaris? That should be Polaris there. Still not quite dark enough for me to be able to see really well. And bright light shining in my eyes have pretty much killed my night vision and will for the rest of the night. That's okay, I'll suffer. Where is Polaris? Alright. And a billion cables over here as well, so that'll be, it won't trip over anything. Is it? So, instead, let's do this. This is really entertaining, isn't it? I have an application on here. Let's see if I can find it. I used to have one. GPS status. I probably should have used this before. Okay, that's fine. Now I need to find where north is. It's a nifty little application. Well, you can see that, but it will let me point to north. I have to just get it right. That can't possibly. Well, this is fun. Nope. I have to calibrate it. That's calibrated. So, calibrate the compass, make sure that it's pointed in the right direction, and then hopefully it'll work. Okay, north is in that direction. Is that just... No, I'm off. I just don't know where Polaris is. So here's what we're going to do. We're going to wait. We're going to wait because I can't possibly get alignment right now. Instead, the moon is bright. The haze is going away. Let's just get something on the moon. And I will start moving it over. So what I'm going to do is manually move the telescope over, and we'll do the alignments later on. We can talk about other stuff while the alignments are going. Here we are. Moving this way over. Velcro sound that you hear is actually Velcro. We use it to keep our cables from getting in the way. All right, let's see what I can find. I'm still waiting. That should be pretty close. All right. So I've got the hand pad here, and again, I have no idea where Polaris is, so let's go ahead and switch over to something else. I'm going to switch to Sharp Cap. So again, I have not actually, oops, that's not the one I wanted. Definitely not the one I wanted. So I'm going to go ahead and switch over to a different application. And this will go ahead and actually let me bring up one of the cameras, and then we can do the focusing on it and make sure it's good. Try this again. There we go. Always have teething problems, all right? Let's see, who do we have here? Saginaw, we have Burleson, AJ. So usually I am from doing this from Burleson, but not tonight. Actually, I have a couple mosquitoes there on my monitors, but that's okay. They're staying out of my way. I'll be quite happy. There we go. So I want which camera? Ooh, I've got a couple cameras to pick from. So let's do this. Let's switch over, and I'm going to go to. There we are. Okay, I've got a couple cameras. I've got the Polemaster and that one. So we're going to switch over to this one and see what we got. I was using this earlier. I see nothing. Oh, that's probably because my exposure is way down. Way down. Hello. You know what? We're going to switch something else. Backyard EOS. Yeah. I think the other camera is connected. It should be. Oops. Right, this application lets me connect to a Canon camera and then control everything from here. This is actually connected to my modified astronomical camera. So this is a Canon DSLR. It's connecting, yes, good. Okay, so this is a Canon DSLR, and it is modified to allow me to take photographs with it. Well, I don't see anything. Do you? I got nothing. Alright, so now we got to figure out why I've got nothing. Why is it pointed at nothing? It could be because it's not tracking it, but let's find out for sure. Not tracking, this is not going to be much fun. Finder, yeah, it is not tracking. This, there we go. Will be a bit of a problem. But we'll figure it out as we go along. I'm going to go for a much slower move. And we got to focus this thing. This is totally out of focus, isn't it? Yep. Reverse. Go down. Now that's a nice blurry moon, isn't it? Let's get that in focus. So I've got a focus knob right here. In. Way in. That's halfway decent, but not quite. You can see some double images right there. So let's really get in there, 5x. There we go. That's just nasty. So instead, that's pretty good right there. But now we have a problem where it's moving off our field of view. And that's going to suck. So we're not going to be able to use this thing very well. But just taking a quick look, we can see a range of mountains right there. I believe that is, I think that's the Lunar Alps that we're looking at right now. And that's Mare, the Sea of Rains, Mare Illibriatum. I can't remember what it is. It's, I believe, the Sea of Rains. It is a mare, and that does look like it's the Lunar Alps. There's a valley right over here. Yeah, there's a valley that goes right through there, so I believe these are the Lunar Alps. This is basically an uplift region alongside of the mare, so basically a big asteroid, 150 kilometers, roughly smashed into the moon 3.5 billion years ago, and it punched all the way through the mantle, and then that mantle material comes up, and that's that basaltic darker color mare, and then the edges of the crater are, the remnants of the edges at least, are those lunar Alps, this mountain range that we're looking at. And now we're looking up towards the north. This is the north pole of the moon. Yeah, so we don't have any tracking right now, which that kind of sucks. So let's go ahead. Oh, and the red color is because this is a modified camera, so it's a lot more sensitive to red light. It doesn't look like a normal moon shot where everything is gray. But yeah. All right, I think we're going to have to get. Let's see if I can find Polaris. I can't because there's a cloud right there that's coming down. So instead, we're going to do this. Oops, wrong direction. I'm just going to reset this thing back to 0. And by resetting it back to 0, it will give me the opportunity to go ahead and do the alignment. And I have an automatic alignment system for it, which is really nice and handy. All right, so we're going to do this and enter, align, enter, start. Okay, so let's let it do its thing. Put it on the ground because I have a better place to put it right now. So what this has, I can transition over to a different, let's see where it goes. There we go. So what it's doing, and I can't really show you on here except, oh, let's see. Right back there is a camera, not the red one. There's so many cameras on this thing. So back behind there is a camera called the Celestron Star Sense. And what it does is it will take a picture of the sky, fairly wide field, and then compare it and tell me what stars are, or it tells itself what stars are in the field of view. Then it goes to another part of the sky, takes another picture, figures out what stars are there, and does this for the whole sky. It does usually between 5, 6, 8, 10 images, depending on how cloudy it is, how bright it is, a bunch of factors. But once it does that, it knows what it's pointed at. And it knows where to go in the rest of the sky to go find something. This is really nice because it used to be you had to do everything manually, or we did a 2-star alignment, so you had to go find 2 stars, point to one, point to the other, then point to a third one to get a better alignment. This way I hit one button, and instead it does all the work and I can talk to you. Works out for me. Or if back when we were doing in-person star parties, I could hit a button and I could continue getting ready. I could talk about other stuff while the telescope was doing the alignment. So it's doing its thing. Is it ready? Nope, it is still figuring out what it's looking at, doing all its calculations. That's fine. In the meantime, let's go look at the moon. So I'm going to switch over to here. All right, here's what we're looking at. This is the application. It is not pointed to northeast. Well, it kind of is. So this is already connected to the telescope. It is telling me what it is pointed at, roughly where it thinks it's pointed at, but that doesn't really concern us right now. We want to go look at the moon. There we go. Let's go take a look at the moon. We can see what we were looking at. There we go. So this application is called Starry Night. This is the Pro version. It's a little bit more expensive, but it has a lot more features that are really, really nice for amateur astronomers. And what I can use this for is actually coming in, and it will tell me what I'm looking at. So this is what we were looking at earlier. We were looking at the northern part of the moon. The southern part is just riddled with craters. That's one way to tell the difference. If you're looking at the southern pole of the moon, craters, 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 absolutely everywhere craters. If you're looking at, if you're looking at the northern part of the moon, there are more mare. And actually on the far side of the moon, we don't call it the dark side because it's lit up just as much as this side of the moon is. but the far side of the moon has a lot more craters and a lot fewer mare. And what we think happened is the moon's gravity actually protected Earth during the last couple of great bombardments. What that means is stuff that might have hit the Earth, had it not been for the moon, hit the moon instead. So the far side of the moon is covered in craters completely. The near side was not hit as bad, and so we still have large mare. We don't have the number of craters that were out there. So here's what we're looking at before. We're looking at this mountain range right here, the Lunar Alps, and that valley was right through here. So yeah, sorry, it's kind of, I don't want it centered. I want to, yeah. The problem with this one is that as soon as I start moving it, the moon moves. So actually what I can do is this. I can just pause it. Let's just do that. We'll pause it. Show all labels. View. Where was it? I want space missions. I can't remember which ones I have. So I have a newer version, I have an older version, and I have the older version on here. So I want to find tonight sky. It's not really what I want. I want the moon, Earth, the moon. What do I want to do? I want to see show info. No, not show info. I always do that. Where is it? Show events, cursor tools, angular separation. No, it's not what I want. Just lunar events back. Don't really want lunar events. I don't want the orbit. Yeah, what I was actually hoping is it would tell me, mark Lynn on the surface. Here we go. So we can do this. Mark Rima Hadley. So this is a rill. That's through here. A rill is basically think of it as a valley. What it actually is, it's a crack. So a rill is a place where you have tectonic movement on the moon from basically the moon contracting. And what happened was you have basically two chunks of land like this, and one moves up like this. Or you have a situation where it spreads out some and the land inside drops. You can have all sorts of things. In this case, this is a valley that goes in between the mountains. It's not so easy to see on this one. I wish I had put the better version, the newer version on here, but I didn't. So maybe, do I have it on here? I will see if I can get this thing working. Maybe. We'll see. So we're looking at this rill coming through here, this valley. But these are Mons Bradley, Monsoon. Yeah, so these are the Alps. This is God, so many craters. All right. While we're doing that, this says alignment failed. Ooh. Good enough for position. All right, fine, back. It is not that great. So where is Polaris? There is still a cloud right there. There's still a cloud covering Polaris. I can't believe it's covering Polaris. If it wasn't covering Polaris, I could actually do this fairly quickly. I cannot see Polaris. It is a dark sky. But we got enough high clouds that it's annoying. All right. Someone's asking about these lines. These are basically fault lines. So the moon is old. It's smaller than the Earth, and it is in fact contracting. So as it cools down, as the moon cools down, here's the moon, enter. Okay, there we go. That'll be better. Just like anything else, as it cools down, it contracts. Because it's contracting, you have places where, again, the land is doing this, and then it gets squeezed together, and a little bit pops up, a little bit pops down. These are areas like that. Oh, great. Now I got moths coming to the light, too. Oh, of course. Why wouldn't they? So these are places where you have contraction, where part of the ground slips down, part of it slips up, and so they're basically cliff lines. They're all over the moon. We also have some lava tubes. I believe there's some lava tubes on the moon. I think there's actually one that's it's like this. It's an almost permanent little hole because it's think of it like a sinkhole going down. I just don't remember where it is. And only at certain hours does the light go down into it. So it's kind of rare to catch it during the day on the moon when it's actually the nighttime here, just to be able to get the light down there. So I have someone asking about doing this kind of stuff for the astronomy classes at UTA. One of our dark sky sites used to be the dark sky site for UNT. And UTA does not currently have one. I believe it's the Olympus Mons Astronomy Club there. They do not currently have a dark sky site, but we have talked to them before. Our club is looking for additional land for our own dark sky site, and I hope that once we have that, we will be able to help a group like Arlington use that for some of their equipment. So let's see. All right, got that. It just pointed right. Oh man, that just, I'm not happy about that balance, but let's see. It's not pointed at the moon. All right, let's bring this up. Let's see what it is pointed at. It's pointed over here. That's not where I want it to be. All right, let me fix it, get it on the moon, and hopefully it'll track. Wrong direction. Many cables. So looking at where you're at. That's nowhere near the moon. That's not anywhere near the moon. Okay. So, way off. It's not anywhere close to it, so let's do this. I'm gonna have to hunker down. I don't know if y'all can see me, maybe kind of. So I have a red dot finder on this thing. Just really, really uncomfortable to get to right now. It is way, way down low. And it hurts right now. Let's see, red dot. What's worse, what is absolutely worse right now, right when I got here, one of my cousins said, by the way, we got water moccasins and they come out at night. And there's a small ditch full of water right behind me. This is not any fun. I can't use this thing. This is completely ridiculous. Yeah, it's in this weird position that I can't actually get in there and use it. So instead, let's see if I can do this. Slew to the moon. All right. Let's see if we can do this manually. We will be able to do the alignments. So, does the moon have earthquakes? No, it does not, because it is the moon. It has moonquakes, and it actually does. It is because of the cooling. It does not actually have any tectonic activity like the Earth. It is far too cool for that. Now, there's no active magma anywhere near, and it has a minimal magnetic field. However, let's do this. I'm going to switch to a different camera. Let's see what this does. RGB. Yeah, fine. not getting anything. 5 seconds. All right, what I'm trying to do is get at least something in the field of view. I've got nothing. So let's try this again. Something. Anything, please. Okay, so I've got a little mirror on here that hopefully will make it easier to see. It really doesn't. It just seems to be way off. Not sure how to get it over without painful contortions. All right. Oh, wrong direction. I got something. Got cables. Not happy. Yeah. What is wrong with this? Always a problem. Cables don't quite connect the way you want them to. That's okay. Maybe this will be a little bit better. Okay, what was that? Anyone see something bright? I'm not seeing. Right, once more with feeling way down. There we go. Well, that's bright. Think that's bright enough? I think it's probably bright enough. Okay. Go. What I'm doing right now is I'm trying to get the moon on a guide using the guide scope, and this is just way too much of an exposure. So how many seconds do I actually need? Something like that. Probably less than that. Probably do not need LX mode. Quick picks. Let's do. I'm just trying to get something right now. Anything at all. Okay. Well, that's interesting. Two seconds. That's still not right though. All right, but I think I'm closer. Let's see. Terribly sorry about all this. Okay, once more. Where's my light? There we go. Here we go. That's going to be way too bright, but that's quite all right. Let's cut that way down. Not 2 seconds. Something like that. A little bit closer. Okay, now I can focus, maybe. And let's go ahead and cut down that exposure. Way down. Way down. All right. So now we've got something, but it is still moving. So my alignment still isn't good. It's just not good. But we can do a focus. Okay. Now at least I have something in the field of view. It's not great. It's good enough. Let's switch to the camera. There we go. Anything? Nothing. That's just great. All right, how about this guy? Yep. Nothing on here too. So, well, there's my problem. I just don't have it aligned right. All right, let's see if I can see Polaris this time. There's a cloud still covering Polaris. I can't believe I can't see Polaris. Can't actually see Polaris. I see where it should be, and there is still a cloud covering it. All right, well, this is disappointing. Pretty disappointing. So where does this say I am? It says I'm way down here. No wonder. I just can't do it. All right, we'll do this. Back. I'm gonna have to move it back where it was, and we'll just try again. You know, sometimes I've been up half the night and not been able to do anything with my equipment. And that makes for a horrible night. And tonight I actually thought, maybe, just maybe, be able to catch some dark stuff. And I think we should be able to. Once you get a good enough alignment, it'll be fine. But it's just getting to that point. This is why usually I try to do it the night before. If I do it the night before, I can get all the bugs worked out. The only issue is I'm not really happy with leaving it out here all night and all day. And one of the reasons is my cousins have a whole mess of dogs out here and a whole mess of cats. And as I was setting up today, one of the dogs just came over and threw up right next to my equipment, so that was fun. And I wasn't really expecting that, but okay. That's what you have when you have a lot of dogs. We have two cats at home, and they also throw up, so I guess I'm kind of used to that. Yeah. All right, well, that does the alignment. There's a whole bunch of other stuff that we can see. I'm going to turn off all these labels. We don't need so many. So I want to catch some of the neat stuff. We're going to get bright NGCs. We'll get the Messier objects. And that should do any planets moons. We'll see what we can get. Oh, we got the Leo triplet nearby. If anyone was watching earlier, we had the SpaceX Demo 2 mission that launched from Florida this morning, this afternoon. It was scrubbed yesterday, and they did today. I think it was about 2:30 Central Time, so we got to watch that. It was really neat. I don't think we'll be able to see it. What I can do is try. Let's see, where is my little application? IS Online. We'll see if there's any IS passes. I don't think we have any tonight. Saturday, 22. Oh, no, we already had it. We had it at 8. No, 10. When is this? 22. 10:25. It's at 10:25. It'll be visible in 40 minutes. Okay, cool. So from here, we'll be looking towards the north, and it will pass low on the horizon. So actually, may be able to pick it up with one of these cameras. Can't guarantee anything, but it will be low to the horizon, so it probably won't be terribly bright. See if I can find the magnitude. 0.5. It's not going to be really, really super bright. But definitely the Dragon capsule is too small to pick up. We're definitely not going to be able to see that. Alignment failed. Alignment actually failed. All right, I'm going to try this again in a different way. I'm going to move it closer to where I think Polaris is. You know, I might as well. Might as well. I mean, what's the worst thing that'll happen? I can't really break the equipment. Yes, I can. I'm not going to break the equipment. You can always break the equipment by doing something wrong. In this case, I see Polaris. I think it's Polaris. Is that Polaris? That is not Polaris. So what am I looking at? Let's go over to here. Let's look at the north. What am I looking at? What am I looking at? Mercury. Oh yeah, Mercury just barely above the horizon, but because of what I'm looking at over here, we can't really see Mercury, which is really too bad. We were messing around with too much stuff in order to make it work. I don't know why that's pointed out there. Where are we looking? Cardinal directions. Labels. Why? North. Here we go. Hide all labels. So pointed. This is what I'm looking at right here. What are we looking at? This is Vega. It's actually Vega? I am way off. There's Polaris. So if this is pointed out here, oh man, I am way off when it comes to it. Ooh boy, this is gonna suck for actually aligning it. So, north is nowhere near where my cousin said it was. I'm pointed here. Polaris is right there. Polaris is right there. Oh boy. Alright, let's see if we can make this thing work. Fun. Here's what we're going to do. So the mount actually has ability position. All I have to do is undo some screws, start moving the whole thing. Problem is, I don't know if I have enough range to move it that far over, but we're going to try. Oh boy, we're going to try. And very carefully moving it over, over. If this doesn't work, I actually have to pick this thing up, and I think, how much weight does this thing have right now? This is 40. This is probably about 120 pounds, roughly. It is not fun to pick up. All right, let's try this again. That is almost there. That is so painfully close. It's like yeah, that's like a couple of degrees off. Oh, man. That is so close. I have to yell at one of my cousins, or at least well, that's not gonna work. So I have to find that hole again. I found a hole. But this is okay. There is a fix. I don't like to do it. Here's the fix. Hope that's enough. I definitely don't like to do that. But where is Polaris? There's now Polaris. I've moved it over too much, which is perfect. Okay. What you doing? Oh, nope. Oh, yeah, I just picked it up myself. Oh, yeah. I do call. So you watch your life. Oh, great. So one of my other cousins is watching and told my other cousin to come over here and help me. So I'm fine, thanks. I have to figure out what I'm looking at now. You need to go a little bit more over. Alright, so I moved it over enough. Now I can send it back. And we're going to go use the polar alignment scope. So we have 34 minutes until the IS passover. So if you're in the Texas area, go ahead and I'll go ahead and let you know. But you need a view of the sky to the north. And what I mean by north, it will be 15 degrees above the horizon. So if you look out at the horizon, 15 degrees is, let's see, how much is it? Think of it just over 3 hand widths extended out is going to be roughly 15 degrees. So that's what you're looking at. If you can't see 15 degrees up above the horizon, don't even bother going out. If you can, it will be towards the north. It will actually come out right at north, and then it will move towards the east. It will be, again, low on the horizon, but it will be visible. Is that it? That's not it either. So what we're looking for is Polaris. Let's see if I can just get it centered. So I'm looking through a red dot scope. It is way too high. Okay, cool. There. One up. The other side is the polar scope, and those are my fingers that you can see. Now, I drop it. Make sure Polaris is right there. Bringing it down. I should see something bright. Yeah. Okay. Maybe I should try doing it from this side. Is this entertaining to anybody else? Because I don't find it terribly entertaining. There we go. Yeah. All right. Yeah, it's heavy, it's expensive, but it's a tripod. The weight of it is balanced just right, so I don't have to worry too much about it tripping over that much. Especially if I'm not going to move it that much. Over. Kind of like theater, isn't it? Pretty close. Do we see Polaris there? I still don't see Polaris in the field of view anywhere. Be soon. Anything at all. A little bit over. Getting close to that edge. And I'm not even properly centered, that's why. I should be closer. Yep, I still have to move it over. It's just really hard to zero out. According to this, over to the other side. All right. Once more. Loosen these up. And then push it off. Again, is anyone else entertained? I hope someone's entertained at least. And this is why you do it the night before, not the night of. But, I don't know. We'll be here for a while. I'll be here for a while. Absolutely worst case. Watch this on the rerun. If it's bedtime. Okay. Now, did I miss it? Let's just keep going. Are there any stars that are popping up in the field of view? Or did the camera get disconnected? I don't think so. I'm just not seeing it. Yeah, Polaris is usually big and bright. Should be really, really obvious. Not even close. I'm gonna move it again. This is not even close. Okay. More. Freeze. Okay. This is dead reckoning trying to do, and it's still not right. Alright, might as well move it a ton, right? Okay. I hope no one's getting worried. You'll be fine. Close. A little more. And always remember, the trick is pull it toward you, not away from you. Pulled away from you, you risk having it fall over. Pull it towards you. Your body will crush it. Or your body will soften the blow. There. Now it's still not right. Wait. I see something bright. I see. Alright, let's do... Here we go. I see something that looks like Polaris. Is this Polaris? This is Polaris. Cool. Alright, here we go. That is Polaris. It's big and bright. Yay! Yes, fine. Okay. Double-click Polaris. So this is the alignment process. Double-click Polaris. And slide it to match that. That's good. Now, I have to take this thing, move it to the center of the small... Okay, so where this is, I have to move it right to there in order to make this thing work. That is totally doable. So here's the trick to this now. I do it. Wait. What do I do? I move Polaris into that. Cool. Okay. That's doable. Get that roughly right there. Okay. Now, there we go. That's so close, isn't it? I gotta get it just a bit more. What? That's probably good enough. Good enough for what we need. Finished. Does it match? Success. Don't need to start the monitor. Okay. Step one is done. That only took a little bit of muscle. Okay. Alright, so here we go. Back, align, enter, align, align. Haha! And that is the last time I take my cousin's instructions on where north is. Okay, so here we go. Let's get the, you can kind of see what's going on behind me. So, we're now aligned towards north, finally. The telescope is doing its thing. You can see the counterweight back here. So this weight back here, this is 17 pounds plus 5 pounds. So 23 pounds, which counterweights however much I got in there. I think total that's 50, 30, call it roughly 30 pounds of equipment over here. Maybe a little bit more, especially since I have some plates which kind of weigh a whole lot. This is a double telescope setup. This is not something that's typically done. Most people have just a single telescope, and they'll have a little guide scope. On this one, I kind of have 3 telescopes, 1, 2, 3, 4 cameras. So it's kind of overkill on the weight. But as long as the mount is balanced well, it doesn't really matter how heavy it is, except for, I guess it does kind of matter. You're not going to be able to take a mount that can handle 15 pounds and put 150 pounds on it, even if you balance it perfectly with a whole lot of weight and a long, strong counter arm. You're still putting a whole lot of pressure there on the system right in the middle. But this mount is rated for 40 pounds of payload. I'm underneath that, and I added on some additional counterweight to balance it out. So it's actually fine right now. And using the 2-scope system, it's really effective for me to do, especially at star parties when we do our public events, because I can have a wide field eyepiece in the wide field scope, so they can see, let's say we're looking at the moon. So with one eyepiece, you can look at the entirety of the moon. You can see, and you can see the entire half moon at the time, because we typically do our star parties during the first quarter. So you'll be able to see the entire moon in one, and then you look over the other one, and I may have that zoomed in on a crater or mare or lunar Alps, for example. Something else where it's a small field of view, but you can really see a lot of detail, and we can talk about the craters, rebound mountains, the moths are coming out. Okay, back to the moon. So one eyepiece you see all of it, another eyepiece you see a detailed view. And it's really effective, especially for getting a long line of people through, because now I can do 2 people at the same time. Someone looks at the moon, the wide angle field of view, and then they move on and they can see the narrow field of view and go off and go find another telescope, and I can just keep moving the line through, and it's really, really effective. And this says now, aligned, enter to continue. Well, gee, who would have thunk it? All right, let's see, where are we? Where are we? Where? What are you pointed at now? All right. I need cardinal directions, labels. Really? Okay. Southwest moon. Where? There it is. There. That's what's pointed. Okay, so we're going to go look at the moon. We're going to slew to the moon. This better work. This better work. So let's see. We're going to transition over. Okay. Let's look for that red. There we go. Now it's coming in. It's updating. I hope this works. I really hope this works. So it's overshooting it, and then it comes back in. Let's see just how accurate this thing is. It's not bad. Not good. Not bad. All right, so this is way too much of an overexposure. Let's bring this way down. Way back up. All right, which camera is this? This is the... Good. This is on the teleview. So let's do this. I'm going to bring this up to 100% and go way over. So this is a 6 megapixel monochrome camera. Focus it. There we go. There we go. That is not bad. That's not bad on focus. All right, let's 100%. Let's zoom in. I want to get a little bit closer. Let's do 200%. Okay, and we're going to knock the exposure down because I want it a little bit darker. Oh yeah, there we go. A little bit more. All right, so I'm going to very, very gently, wrong direction. Go look at the Terminator now. Yeah, here we go, Lunar Alps. Remember, we are looking at it just totally different direction. Up, over, wrong direction, over. So everything is all messed up with how you're looking at it. This is what we were looking at before. These are the Lunar Alps. Did I lose my connection? Let's try this again. I'm gonna check the other camera. Oh, there we go. Okay, we're actually fine. No, we're not. We're gonna do this. Let's see if I can get this right. Because I did a quick alignment earlier. It wasn't quite what I wanted. Okay. Back. Now let's go up. Yeah. It's totally reversed. We're gonna go look at the Lunar Alps again. So I've got this. And what I'm trying to do now, I've got one more physical thing to do. There we go. So we're looking at the Lunar Alps right there, roughly centered. And what I want to do is come back to here, and now I don't see anything. Oh, it's down here. Cool. So what we're going to do is get it to 50%. Yeah. So I want to get the Lunar Alps right here in the middle. And the way I do that is I physically mess with this thing. So I actually have a nifty little device on here that lets me move telescope. Here we go. Do this. Oh. Let's get it right in the middle. That's good right there. So I have a little device that the TeleView sits on that lets me move it up, down, left, right on the X and Y axes, so I can go ahead and do stuff like this. So we're going to go way in, and again, here we go. So these are the Lunar Alps all the way through here. Here is real Hadley coming right through there, and we've got a number of craters. See if we can find something interesting in one of the craters. Okay, here we are. Here's a very large crater field, and what I'm going to show off, and I'm terribly sorry about all the dogs. Hopefully it's got dogs on one side, dogs on the other. Okay, so what we're looking at here through the little bit of haze, some atmosphere, we can actually see some cliffs along here, some rebound mountains in the middle of craters here. It's not half bad. So let's look over here, and I'm going to zoom in 5 times. I'm going to do 400. Let's see if we can make it. Yeah, so we can see another rebound mountain right here. Let's see. Let's compare the two images. So here's the Alps, and I'm going to zoom out. Back up to 150%. Lunar Alps, and what we're looking at is this crater right there. Let's see. Yes, that one right there. So let's brighten that up. Oh yeah, there we go. Now we can see some details. All right, that looks pretty good. So anything? Cool. All right. Okay, so here's what we're looking at. This is a crater here, and we can see some cliffs all along here in the mare. So again, these are places where the land basically just dropped down just from the cooling of the moon. So this here is a rebound mountain, and you see these on larger craters. You don't typically see them on small craters. Small craters, meteoroid or an asteroid hit it, and gouge out a big hole, and that's it. Meteor Crater in Arizona is a really good example of that. It's a crater, it's a hole in the ground. The larger the asteroid is that hits it, the more damage it does. But what happens is it doesn't gouge out a hole, it actually melts the material underneath it. So when you have something which is several hundred meters across that impacts at a high velocity, it will come down, hit, and then melt the material, and it will splash out just like it would be a water droplet hitting, a pool of water or a cup of water. It will splash out, and then it will come back in because gravity is now forcing this molten liquid material to slump back together. So it comes back in, it starts bunching up in the middle and creates a rebound mountain. And basically what happens is it just freezes. So if you've seen movies of water droplets, when they hit the ground or when they hit the pool of water, they'll splash out and it'll come back up, and there'll be a little bitty droplet just at the top, and then that falls back down. Well, in this case, it comes back together and just freezes. There's probably some splaying of material that goes out again, but it just freezes into a little mountain right there in the middle. And what's interesting on some of these, and I don't know if we'll see them, but let's try to find one. So I want to find. Oh, here we go. Here's a good example. Let's see, which crater is this? I don't remember, but that's okay. We can always find it. Is this 8? Nah, let's do mono 16. Let's get a better image out of this thing. There we go. So I'm going to do 100%. Let's go over. Here we go. Some of these craters here. They don't have rebound mountains anymore. They've been filled in from the mare material. So this is an impact that was hard enough that it punched through the crust into the mantle, and that molten mantle material during this bombardment period flowed back up through and filled up the valley at the bottom of the crater. So I'm going to zoom in some more, and we can see something really interesting. So these craters are large enough, and you can see the shadow doesn't extend down towards the middle. And on here, it's closer to, or further from the terminator, it's more towards, it's later on in the morning, you could say. So the shadows aren't nearly as long. And you can see here's an interesting mountain. This one has a very, very long shadow as it goes out. That shadow is a lot longer than the mountain is tall. And you can see the shadows on here from the edge. For some of these craters, if you were standing right here in the middle of the crater and you looked out towards the edge, you would just see a flat plane. You wouldn't actually see the rim of the crater. It is so far away that it dips down below the horizon line of your position on the moon. Now, if instead you were on let's say there was a really tall building or a space elevator, let's do that. Let's do a space elevator right here from the middle of this crater going up. If you're on that elevator, you start off and all you see is a flat plane. As you go up, 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 you would see the walls of the crater come up on either side of you, actually all around you. And then you would realize, hey, I just came out of a crater. But not if you're right in the middle of it. You have the Alps down here. Here's another rill. Again, I'll have to come in and look up their names. Let's see. I'm going to stop it. Yeah, so we were up here. We're looking at the rills through here. So what are those craters? This one is Archimedes. Okay, so let's go back. So this one here is Archimedes. Archimedes. We have Archimedes right there. And then we have Autolycus and Aristillus. So we have Autolycus, so Archimedes, Autolycus, and Aristillus on there. And then we have them right there as well. So, what do you know? Our map of the moon is accurate. Let's go over here. What is that crater right there? Let's find out. Again, we got to go to Terminator, go up, up, up. That would be this one. So this is Plato, another famous one. We have a number of craters. Aristoteles, So most of the craters on our side are named after scientists. Some are Greek, Greek mythology, things like that. But mostly it's scientists, it's it's like famous people. On the far side of the moon, a lot of stuff is named after Russians, because it turns out that the Russians were the ones who first sent a probe around and took images of the far side. And so, well, if you're the first one, you get naming rights, right? So that's what happened. Down here, let's take a look at some of these rills, some of these other features down towards the south. So we have a mare here. We have some, here we go. This, we got Tycho. Well, that's further off. We can get to this one. If you look at these bright craters here, these are going to be the younger ones. This crater right there, let's find out what that one's called. This one, you can see these ejecta lines that are coming off of it. And what these ejecta lines are, when it hits, material splays up and goes out, right? It just flies out in all directions. It doesn't fly out evenly in all directions. Sometimes there's more material in one direction, especially if it comes in on an angle. If it's hitting on an angle and then goes out that way, or in this case, goes that way and goes that way, more material is going to fly out in one direction as compared to the other. So we don't see a whole lot of stuff here. We see stuff in this direction. And sometimes you have these ejecta lines, and we can see these with Tycho. Let's see if we can... I'm going to zoom out. Tycho's down there. So let's see. Go in, and we're also going to go over to the southern polar region. Oh, there we go. So I like this camera because I can get the entire moon in the field of view pretty easily. Oh, we got some clouds coming in. Well, that's nice. All right, let's deal with what we got. We can always do a longer exposure if we have to. Okay, so we can see some of these ejecta lines from over here. This would be Tycho. I believe that's Tycho. Let's make it a little bit longer of an exposure. Make it a little bit brighter. Yeah. So we can see some of these ejecta lines coming out, and it's the exact same thing. It'll hit, and then... wait, that's not Tycho. That's something else. I can't remember which one that is. Tycho's not even visible right now, is it? Let's zoom out again. Yeah, but these are ejecta lines that are coming out. Really? Really? Yeah, it's just high cirrus. And what's bad is that it's this one cloud which is now covering the moon. So it's one cloud. That's just perfect. That's just absolutely perfect. All right, we have 6 minutes, 19 seconds, 18, 17, 16 until the IS pass. 6 minutes, 10 seconds. So I'll go ahead and let you know when it's a little bit closer. But yeah, thanks, clouds. We're just about to look at something interesting. So a little bit brighter. Let's do this. Let's go down to the south anyway. So I can make a longer exposure. Go down to the south. We got clouds. That's fine. We can make out some details. So down here in the southern regions, the south pole of the moon, we have something interesting where we have craters where the sun never shines into the bottom. And turns out there's water. So when we go to the moon, one of the important places will be the southern pole, because we will be able to mine it for water. And then you take water and you melt it and you purify it and you can drink it. You can also use solar panels to generate electricity. And once you have electricity, you do electrolysis on the water and you separate it out into oxygen and hydrogen. You compress the oxygen and hydrogen and you get a liquid phase. Once you get the liquid phase, you have rocket fuel. So what do we got? 5 minutes, 4 minutes, 50 seconds until IS. That was a little alarm on my phone. Once you have rocket fuel, now you've turned the moon into a refueling station. So that's one of the reasons why it's important to go back. It takes a whole lot less energy to shoot rockets off of the moon than it does to shoot them off of Earth. Also, something very interesting about the moon, because it rotates so slowly, it's not a huge amount of power difference to shoot from the equator as it is to shoot from either of the poles on the moon. On the Earth, we have rotation. And one of the cool things we can do is if you put a launch pad close enough to, or near the equator, as the European Space Agency does, you get an additional boost off the rotational speed of the Earth. If you go further north or further south, you actually have to build bigger rockets, more powerful rockets, to get that same speed going into orbit. So you can use smaller rockets from the equator than you do further north or further south. But on the moon, because it's rotating so slowly, it makes one revolution per orbit every 29.25 days. Then there's not a whole lot of a difference. So the gravity is 1/6 of what it is on Earth. You don't get much of a rotational boost comparing the South Pole or North Pole versus the equator. So you build your refueling station at the South Pole, and you shoot off rockets from there. And you do actually have to do some orbital translation, so you have to get you have to use more energy if you're going to do something like orbit the moon on a equatorial orbit. But that's not necessarily a really bad thing. Excuse me. It's just orbital mechanics is what you have to do. So some of these craters way down here, not that guy. If you can see the bottom of these, then those aren't the ones we're talking about. But the ones right around the South Pole, those are the ones that have water down there. And here's what we're looking at. This is stuff down here, right along that terminator. So what is this one? This is Mauritius. So we were looking at Mauritius earlier. One of these. Mauritius. I believe that's that one right there. Looks like it. I don't know why I have to double click it. Well, it's actually really hard to tell. There's so many craters all through here. Just riddled with craters. And this one is Tycho. Here we go. So Tycho's right close to the terminator. Let's see if we can find Tycho. Tycho's going to be one with a whole bunch of these rays, these ejecta rays coming off of it. Let's find Tycho. Keep trying to drag it. No, we don't see Tycho yet. Unless that's Tycho. I don't see any. Well, that could be. I got some rays over here. See these rays? There. The one right there. Alright, hang on. Alright, that's too much. There we go. Now you can see those rays. Okay, a little bit more. More contrast. There we go. You can see these rays through here. Right through there, and we're just going to get blinded again. Why can't I find a happy median? I can't. Because the clouds keep coming in to make it better, making it worse. Here we go. So here are the rays. There's one, here's another one, here's another one. And they all point back to something. What do they all point back to? Tycho. Back to here, roughly, somewhere. So I believe that is Tycho. Let's find out from here. What are we looking at? Tycho. Yeah, it's hard to tell. So we're looking at a big crater with a rebound mountain in the middle. Over here, big crater, rebound mountain in the middle. If that's not Tycho, I don't know what else is. We've got this crater over here as well near it. Try it again. That one kind of looks like it. Let's just call that Tycho for now. Rebound mountain. Okay, 2 minutes, 30 seconds. I'm guessing if you guys want to run out right now in 2 minutes, 20 seconds, I'm going to... Yeah, okay, so I've got one camera. Let's see. Let's get this camera. There we go. So, I don't know. We couldn't be able to see it with this one. It's just so lit up. So I'm going to grab this one and rotate it up. I don't know if I'll be able to pick it up. So let me try something else. Point it up at the sky. So I'm down here. And I got 1 minute 30 seconds. Oh no, it's visible. It is visible right now. Let me see if I can see it actually. No, I don't actually see it. There's a cloud right where it should be. Yeah, there's a cloud where it should be. I can see Vega. I do not see... I don't see it. I really don't see it. It's as bright as it's going to be. It should be... nothing. Well, that was disappointing, wasn't it? I think that was pretty disappointing. All right, well, apparently it's still visible in the sky for another 30 seconds. I don't see it anywhere. So, oh well. Let's go back to look at the moon. Oh, Patrick can see it from Arlington. Oh, well. Good for you, Patrick. I can't see it from down here. It's just not visible at all. So, I am seeing a whole lot of bugs. On the plus side, they're not mosquitoes. I'm sitting everywhere, all over my equipment. Okay. It's fine. Everything is fine. I live. Okay. Andrew's saying I couldn't even figure out how to set up a beginner telescope. So what I went through earlier with getting the polar alignment, this is what you have to do with an equatorial telescope just to be able to use it. For most people, I would highly recommend, if you're going to get a telescope, get a Dobsonian. They're really easy to use. It's up, down, left, right. I was actually trying to bring my Dob tonight. However, a Dob is a visual-only telescope. You really can't connect a camera to it and do video whatsoever. It's just not feasible. Maybe webcam stuff, kind of like this, but only if it's motorized, only if it has a tracking system. Otherwise, it's a pointless endeavor. Don't waste money trying to do it. It is not worth it. But for visual use, it is absolutely fantastic. Again, it's John Dobson, the guy who came up with the design, was a kooky old man, very interesting but kooky old man, and he liked to say it was yogurt powered. You eat yogurt and that gives you the energy to grab the front of the telescope and move it around in whatever direction you want to point it at. But you get a red dot finder. I've got one on this one where once you have it aligned, whatever that dot is pointed at, that's what the telescope is looking at. And I use these at star parties often. And what I'll typically do is when I have this telescope set up and I have the Dob with me, I will find some kid to run it. 8, 10, 13, 14 years old. And sometimes I don't even ask the parents. I'll just go up to the kid. If they look like they're interested, I'll ask, do you want to learn how to use this? And I let them use it. And I've had a lot of success doing that. I've had little kids absolutely, totally excited, and their parents were completely worried that they're going to break the telescope. No one's ever broken the telescope. It was absolutely fine. But it's really neat to get kids to actually learn how to use it. So what they did was, it took literally a minute to show them how to do it. Left, right, up, down, and you point the dot at whatever star you want to see, whatever object you want to see. And then they were showing the night sky to people coming in. So people would go up and say, "Is this your telescope?" "No, it's that guy's." But they were running it for the night, so they were pretty happy. That's something you have to do. You inspire kids, and you let the kids do what they want to do. You don't tell them necessarily, "This is how everything works. This is what you should use this for." You just say, "Here, play with it. Up, down, left, right." That's all I got to know. And from there, the kids figure out themselves, and they do a lot more with it than a lot of adults think. So it's a fun technique. Unfortunately, we're not doing that now because of the pandemic. So instead, we get to do this. All right, so we're looking at the moon. Some more mare. So we've talked about a little bit about the mare. So these are regions where we have large craters. Basically, large craters from large impacts that went through the mantle material, upwelled through it, and just covered it in different colors, or covered it in different materials. This is a darker color than the lighter stuff around. And I think we had a question, where was the Apollo landing? Apollo was Sea of Tranquility. Let's see if I can get the labels on this one. Historical supernova, that's not it. I want space missions. No, yes, I want space missions. I don't see where it is on here. I've got my other one, which does show where it is. Let's see if I can find Sea of Tranquility. And the dogs are out now. They're all around. I don't think you can see them with that camera, but they are running around. On the plus side, they are fairly quiet. So I'm actually looking at my other monitor, and let's see if I can find where this is. This is a kind of a better setup, actually. Do this. View labels, show all labels. It's not doing that. Hide all labels. I want to see. I don't even know anymore. Where's the moon? Show info? No, that's that. Oh. Oh, there we go. Mark that. East Crater, Apollo 11. So here's where we're going to be looking at. I'm looking over here. I'm looking over here. East Crater, these lines. Here we go. You can see right there. 1, 2, 3. So Apollo landed right about here-ish. Right through here. So if you're looking at it, here's the Sea of Tranquility. And you get this crater. And you have, we're going to look for the Sea of Tranquility over here. Okay. So, oops. Is it over here? Well, let's zoom out. Okay. So what are we looking for? Let's compare that. This is Mare here. This is Sea of Tranquility. Okay. That over here? Looks like it's over here. Or is it? Turn your head like this. See if I got it right. Wait, why am I doing that? I can look at it this way and this way. Okay, here we go. So this is a lobe. This is the larger part. We're not talking about this lobe down here. We're not talking about that big crater over there. We're going to here. There we go. Now I know where I am at. That's why it helps to have maps lying around. Okay, we're looking at the Delambre, which is right there. That's it. Okay, cool. So the Apollo landing, this points to, actually that's the Apollo, that's the Delambre right there. We're going across to here. So this little spiky bit points up here, and the Apollo landing is right in this area over here. That's not bad, is it? Just here. Okay, someone said just where my cursor is now. Yeah. So yeah, I went back and I found it. So it's right over here. And the reason why they picked this area for the first landing is because they thought that it would be relatively smooth and they wouldn't have a problem finding the landing site. And in fact, they did. It was quite rocky. There were a lot of really small craters that were smaller than what they could see with the telescopes. Yeah, Neil Armstrong had to find a suitable place, and he was quite close to, not, well, I was going to say bingo fuel, but that's not exactly it. He was at the point where if he had waited any longer, they would not have had enough fuel to achieve orbit again to meet up with Michael Collins in the orbiter, in the command module. So it was fairly close. They had, what, 30 seconds, something like that? It was still really, it was a very tight margin. So they did manage to land. The other sites are scattered around the moon in other places, but some of them were in, let's see, there was one over here. This is Apollo 16, was in the Lunar Alps, I believe. Yeah, I can't remember which one it was over there. I don't have it here on my map. I wish I did. It'd make it a whole lot easier. I thought I had it earlier. But yeah. So, but Apollo 11 is the easy one to find if you know what you're looking for. So again, Sea of Tranquility, and you find this little spiky bit that's coming out, and it's going to be just over to the northwest. It is to the west of where this spiky bit comes out. You can take these craters and kind of line them up. You can be right about there, somewhere in that area. Okay. We'll reject the lines. Let's see if anything changed. I don't think anything changed the last hour or so. But here's Tycho. Yeah. So I got some nice ejecta, and I've got mayflies. No, this, yeah. June bugs are buzzing. In May. Okay, end of May. Anyone else? Anyone else got questions? Yeah. It's the moon. Go back out to 50% so we can see the whole thing there. Tracking is actually not half bad. So this is, again, this is a black and white camera. What I wanted to do was actually take a picture with another camera. However, that wasn't feasible. That camera just pretty much died. What I wanted to do was take a full color image of the moon and then bring it into Photoshop, and I could actually go through the colors and show you what the actual colors are on the moon. Let's see what this does, cameras. I'm going to switch to a different camera. Okay. That's not quite centered, is it? But what I want to do is get it focused. So this is my guide camera. Be careful as I step out. Hogs everywhere. That. Is that going to be focused enough? I think it's going to be focused enough for what I need later on. It'll be good. So the guide camera is it's fairly high resolution as well, and it's a color camera, but what I'm going to be using this for is guiding. So let's get out of the moon. I think we've spent enough time on the moon. And actually, before we do that, I'm going to switch back to here because I want to make sure everything is centered. I'll show you why. Let's go 50%, 40, 40. So I want to make sure the moon is centered. Let's see. Go. Because now yeah, that's good. Let's go back to here, make sure it's centered in here. I like that. That's pretty good. close enough. Okay, the reason I want to do this is now I can come in here and I can see where is this. Well, it's telling me it's over here. Well, that's not true. So I'm going to come over here and say sink on the moon. Now we'll be able to figure stuff out. Okay, cool. So what do we have? We've got a lot of interesting stuff all over the place. Let's look at, here's something neat. Let's look at Leo triplet. Let's see if we can find Leo triplet. So M65. What the Leo triplet is, it is 3 galaxies. Here's the last one up here. Actually, probably, well, let's see what it's going to look like. So the Leo triplet is 3 galaxies that are in a group. I don't believe they are necessarily in the same group. There's probably severe separation. One is closer to us, one is a lot further away. This one's actually fairly dim and edge on. And I'm going to go PhD. There we go. So we're going to go to PhD. Come on, there we go. Okay, so PhD stands for Push Here Dummy. It's a nifty little tool. Where is it? There we go, connect. So we're going to go to that one. Select which camera it is, and I want that one. Connect to it on camera. Good. Let's rotate. Let's see. What's it pointed at? No star selected. 3 seconds. I don't want 3 seconds. I want. Is it pointed? I don't know what it's pointed at. Well, that sucks. 0.2 seconds. I don't know, I wonder 1 second. A lot of noise. So it's taking a 1 second exposure. It's supposed to be taking a 1 second exposure, but something's not quite right, is it? Okay. Well, I don't know what's going on. That's fine, though. We can go ahead and stop that for now. Instead, let's just go ahead to here. So, somewhere in this field of view, there are galaxies. I don't know where they are. Let's see if we can find them. It's going to be a hot chip, but that's okay. I'm going to go ahead and we're going to take a, just for position, 20 seconds. I'm going to make this loud and noisy. 20 seconds, we're going to call this Leo trip. Okay, just so I know what's going on, light, blah, 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 blah. We want a mirror lock. We want a 2-second delay. So this application lets me control the Canon. And I'm going to do 1 capture. So this is going to do a 20-second exposure. And because of the way I have this set up, it will do a 20-second exposure right afterwards. And then it will, with the shutter closed, and it's called a dark frame. So it will take the light frame, right afterwards take the dark frame, and then subtract the dark frame from the light frame to get rid of noise. We don't typically do this when we do astrophotography. We will take our own dark frames, and then we do all the post-processing at home, and take as many light frames as we can with the limited amount of time that we have outside. That would be fine, except for the fact that I'm trying to do some of this stuff live. So it's actually easier just to go ahead and wait and let the noise reduction happen, and then it downloads the image. Let's see what it does, and I'm going to kill the sound because it makes this really annoying beep. Okay, so now it's done with the first image. It's downloading it. Any minute now. Let's see what we got. And it's also kind of... What are you doing? It's a dog. Oh, well. Wonder if it's because I'm shining a light directly into the telescope. That would do it. That would be why the guide scope doesn't work. We actually have 1 star over here. So what I'm going to do now is put on my headlight. I'm going to go kill that light. It's now dark. What I can do is shine one light, and I have a light over here which I can use to light myself up with. Let's see where it is. There it is. Oops. This way you can still see me, if anyone really wants to. So how is it? There we go. So yeah, you can still roughly see me. There we go. Okay. I'll kill this. And maybe now we can try this again. Start the capture. Now if I look up, I do not see light going into the telescope. We can test that again by going to PhD. Try loop again. 1 second. Please download something. Give me an image. Anything. Anything. Right, that looks like it should be fine. Still white. Oh, did I reverse it? Oh no, I think I reversed it. Did I reverse the image? I don't even know what I did now. Well, that's interesting. No, well, something's not right. Something's definitely not right. All right, let's get out of the Leo triplet. Let's go over. Oh, it's the moon. We're so close to the moon. The moon is actually shining into it. Look how close that is. Ah, well, that'll do it. I'll learn something new all the time. All right, let's find something else. We've got comets, which are fairly dim. Wow, man, but that's not going to be feasible right now. Ghost of Jupiter. Here's something interesting. So the Ghost of Jupiter is a planetary nebula. And yeah, so we'll let that thing go. That's going to be in the other. Oh no, well, that's even worse. That's going to be shining pretty down. Okay. So let's just delete that. Try it again. 20-second exposure. Start the capture. I'm over here. This is a LX mode. Let's go ahead and take a 2-second exposure. See what we can find. 1, 2. Anything? Anything? Nope. Need more. 5 seconds. Anything? Nope. Let's see what happens with that. Next image. 14 seconds for noise reduction. Okay, I think this may be too low in the sky as well. Yeah, and this is probably going to get light from the monitors and from the camera. We're not pointing in the right direction at all, are we? Let's just see what happens, but I don't think we're going to get that thing either. Man, I should have planned this out better, right? Let's look at the south. We can go south. No, we can't go south. That's the problem. We're looking south. Instead, we can look out to the east. The east should be fine. Let's see what we can find out to the east. Oh, Hercules. That's always a favorite. Let's go ahead and do that one. First, let's see what we picked up. We got something. Let's see what we can find. We have a lot of noise. We have a lot of light. And I do not see the Ghost of Jupiter. I see just so much noise. And a problem with my camera. There's actually a fault on my camera. It's like a dirty spot on it. That's fine. We're going to go someplace else. We're going to look at Hercules. So Hercules is a globular cluster. And a globular cluster is a group of stars outside of our galaxy. It actually orbits our galaxy. It's about, it's called a halo object. So it is a group of anywhere from 100,000 to several million stars, all in a ball, rotating around the gravitational center, and they are, I believe they're actually older than the galaxy in some cases, and they orbit the center of our galaxy. They will go through the galactic plane, but they stay together because they're just so massive that they orbit the same center of gravity, and even if they pass through the disk of the galaxy, the density of stars within the cluster is so high that it doesn't really have a whole lot of effect on it. I got a big old June bug over here buzzing away. Okay, so we're going to go here. We're going to try one more. Excuse me. M13. M13. Thought I typed it in. M13. Really? Really? Okay. 20 seconds, 6400. They should probably look a whole lot better. Should probably be a little bit cooler on the camera as well. And while this is going, I think I swallowed another bug. So give me just a moment while this thing's downloading, and I will go get some water. Now I have water. Okay, cool. Not quite done yet. Okay, let's see what we got. Any second now. Okay, we got a really noisy camera. I don't see Globular on here. I don't see a glob. Anyone see a globular? I don't see a globular. That's what you should be seeing on here. Let's make a 30. Should do a live stack, really. I get a. Should be seeing something quickly, pretty easily. I don't think we need a live stack. That's fine. Turn off the live stack. But I want to do. Should be saying something. So we're doing an 8-second exposure, and then I should see stars. Should be seeing something in here. Where is it? Where? I'm not seeing anything. So it's not a good sign. Maybe. Let's see what the handset says. Let's see how far off we are. Sometimes the handset is better. So deep sky. Globulars, enter sure. For Hercules, enter. All right, let's see what this thinks. Hercules. Ah, there we go. We had something in the field of view. It wasn't quite right. This is the globular we're looking at that we want to see. Let's see, where are we looking? Oh, it's so hard to tell with these things sometimes. So I've got this. Options, cameras. Switch to a different camera. Okay, and zoom out. 20%. 10 seconds. Let's see what happens if we get a 10-second exposure. Anything. 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 Anything at all. Probably do. Where's my gain? This gain. Pick up anything in the field of view. All right, where do you think we are? Well, it says we're close. Yep, that's fine. Not what I'm looking at anyway. All right, let's just take this one. 20-second exposure. Let's see what it has. I'm not seeing it here in the field of view. On here, it is who knows where. Yes, yes, yes. This is a totally different camera. This is the guide scope, and we don't quite have it in here. So let's find what we're looking at. Sometimes it is not easy to figure that out. Oh, play. Now, the time is right. Oh, my time is way off. Oh, that would do it. So we are doing. Geez, what are we doing? It is 10:57. Okay. Yep. 10:57. 10:57. Okay. That would do it. And how many seconds? 10:58. Okay. Are we actually on there still? No. Well, let's find out. I'm still not seeing it on here. You should be able to see a fuzzy bit. I don't think that's it right there. I do not think that's the right fuzzy bit. We're also pretty... Now we're cooled down somewhat. Okay. I'm going to take a 30-second exposure, less noise. Got it right there. There's that bright star right there. Okay, once more with feeling. Let's see what this does. So 30 seconds. Oh boy. Yeah, not everything's working as well as I'd hoped tonight. It's 11 o'clock. I'm going to keep going. There's a whole lot more to see. We spent a lot of time looking at the moon. I still want to get some deep objects in. I want to try to pick up some galaxies. I want to pick up Hercules because it is quite nice. And this, through a guide scope, that's just not good enough. That's nowhere near good enough. You can see a couple stars through here. Go way up. You can see some points of light in there, but that's not really what I want to see. I want to see something nice, something neat. 30 more seconds for noise reduction. Cows are kind of loud. Let's see what happens. More seconds. So I'm going to come in here and switch to a different camera. Let's just do the same 10-second exposure. Yeah. This time, way out. Fortunately, I don't think the mosquitoes are bothering me. The DEET seems to be working pretty well. I'm going to make this a longer exposure, actually. I want to make this a 25-second exposure and just let it go. See what it does, see what it finds. Okay, I'm not seeing it. Just not seeing it. So that tells me I'm still way off. It's not a good thing. Not a good thing at all. What I want to be able to look around. Just not seeing something. And M13 is one of the brightest globs out there. It's just going to be visible really, really easily, even through a telescope like this, even such a short exposure. I don't know why I'm not picking anything up right now. This is not a good sign. It's not a good sign at all. So, what are we going to do? What are we going to do? Hmm. Just not sure right now. Claims to be right there. I don't think it actually is. M13 should be visible. Now there's a cloud right there too. Now it's not over M13 though. You can pick it up with a guide scope. All right, what else we got? I think I know what I need to do. We need to go ahead and do a realignment real fast, and I'm going to do it on Vega. Let's see what Vega is, or see where Vega is. I'm going to slew to Vega. Slew to Vega. This is a bright star. It's a very bright star. And I want to make sure that Vega is definitely in the field of view. It should be this camera. It should be bright. It should be really, really obvious. And apparently, are we on there yet? It says we're on there. I don't see it in the field of view. There's Vega right there. Off to the top. See, there it is. I should be able to see Vega in here, and I can't. I bet you it's really close. I just can't tell you which direction it is. So let's do it this way. Let's see. Oh, direction. All right, I'm gonna get my exposure down a little bit faster. Where is it? Where is it? Oh, too much. There's a slider. Down to 1 second. Hoping the camera's still working. Yes. Well, I don't know about y'all, it's getting frustrating. I know what's going on, I just don't know why. Nuts. Oh. What I should be seeing is Vega right in the field of view. Slewing around to see if I can find it, and I just can't find it. That is not a good thing. So instead, go back to here. We're going to do planetary. There's Vega. All right. All right, let's slow this down. There we go. Now we got it. Okay. I don't know why I can't see it here, though. I don't know. I'm just going to go back to here. I think we're just having an issue with this, with the application. Yep. Killed it. That's fine. So we got this. That's good. Come back to here. Recenter on Vega. Oh, excuse me. Sync on Vega. Now let's go find M13, not M33. M13 again. Go. Slew to M13. Should be there. Aperture. What happens if I get anything? Not really. It's fine. Imaging, let's try it once more with feeling. 30 seconds. That should get something. Alright, well that's been fun. Alright, what else did I have on here? Sharp cap again. Maybe the older version will work fine. So we just had a crash. That's always fun. And I'm glad I have the setup I have now. 450. Maybe we'll see something in here. Though I doubt it. Something's not right. Something's not right. Alright, while that thing's going, I'm going to go find something very quickly. Let's see if I can pull this off. Here we go. Where is it? I'm looking for 29. Yes. This is big. See. Go. No. Cool. Alright, so first let's see. Oh, there we go. Cool. We do actually have something. So this is M13. This is the globular. Zoom in on here. We don't have... Ooh, focus is a little bit off. That's okay. I'm not going to be grossly picky today. So each of these is a star. Got a blue one over here too. So M13 globular cluster. I really wanted to get something on here, but I think I'm just having an issue with the camera. With the software too. It's just not taking a decent image. One frame. Something's just not right with it. So I may just have to shut down the camera, restart it. But here we have a globular cluster, and again, we have a core, and we can resolve down to the core with an 8-inch, so that's not too bad at all. We can see a lot of stars all around here, and they're colored red just because of the type of filter that I'm using. Or, sorry, the lack of a filter. The chip is naked, it is exposed, it does not have what's called an IR hot filter on top of it. DSLR chips, the CMOS chips of DSLR cameras, they are really sensitive to infrared light. That's not something you want when you want to take a regular picture. But if you take off the chips themselves, the naked sensors are highly sensitive to infrared light. In order to keep them from seeing all that infrared, we put two filters on top of that, the infrared hot filters. So the colors are now skewed more towards blue and green than deep red. If you take off that filter, the camera now becomes really sensitive to infrared light. But all the pictures you take during the daytime are going to look like pictures from the 70s and 80s where the blue and green pigment has faded away and all that's left is the red, mostly. And so everything looks really, really red. You can take some really neat infrared photos with it now. But daytime photos aren't that good. Instead, we can use these for taking pictures of various objects, particularly nebula, because hydrogen likes to fluoresce in a deep red color, and so does sulfur. So a lot of nebula fluoresce hydrogen. So if you got a lot of hydrogen gas in a nebula, and you have hot young stars that are giving off a lot of ultraviolet radiation, the ultraviolet radiation will photon will hit the hydrogen atom, excite it to the first energy level. It will then drop back down because that's what it does, and the photon will hit the electron. The infrared photon will hit the electron. The electron will jump up to an energy level, and then it will drop back down and give off another photon, which is this deep red color. So it goes from high energy UV down to low energy near infrared, nearly infrared, I should say, just a deep red, and then shoot off that photon. So when we're looking at these nebula, we're looking at the excited gas around it, and it is that deep red color. And that deep red color is really hard to see with our eyes because our eyes aren't very sensitive to that color of red light. Instead, we use modified cameras like this that let us see that. So yeah, you can have that done with the camera. You can do it yourself if you're brave enough, if you really want to. If you have like a really old camera, you can do that. So if you have like a 10-year-old DSLR, you don't really use it anymore, and you want to play with it, you can do that. You can also take a DSLR and turn it into a monochrome camera. What you do is you remove the chip, take it completely off, and you take a wooden dowel and you cut it at a really high angle, so you have this really gentle, or actually no, sorry, you want a sharp kind of edge on one side, and you use that sharp bit to scrape away the Bayer filter on top of the chip. And that Bayer filter is what separates out the colors into red, blue, and green for your pixels. So if you get rid of all of that, now you end up with a monochrome chip, and if you haven't broken anything, you put that back inside the camera, and you can test it. You can see what it does, and it should take high-resolution monochrome images. Excuse me. Bugs are now on my water. All right, so we've realigned. Seems to be good. What else can we see around here in the east? If anyone has any suggestions, you can go ahead and type it in, and we'll go ahead and try to grab it. I don't want to try to grab these comets because they're just going to be too dim. It's not going to be feasible to see. But what we can do is just go ahead and jump back down to Vega, because I want to do a quick focus check. Ooh, Starlink. So we have a satellite that's going up. Oh, we got, yeah, Starlink. So this is one of the SpaceX satellites, or technically Starlink, a totally separate company, and just somewhere in there, but it's not terribly bright, so it's kind of hard to see. I'm going to come back to here. I'm going to do a frame and focus. Come on, be there, be there, be there. Here we go. So I want to make sure that it is, well, it's close. It's close. These spikes that are coming off of it, this is a diffraction pattern from the vanes that are holding the mirror up in front of the telescope. That is pretty good. Not fantastic, but it's pretty decent. And what I want to do, just make sure that it's in good focus. And I have a focus screen, and I think I left it at home because I could not find it in my box. So if I get it out of focus, I get it way out of focus, it looks like this. If I bring it towards focus and then back out, you can see this doubling of those vanes. So now you see 8 vanes in weird corners where you only saw 4 before. So what I want to do is bring it in, that the 4 vanes disappear. Sorry, those 8 vanes disappear, and all I have is 4 left. I've gone too far out the other way. Without a focusing screen, it's kind of hard to do, but all I got. I'm sorry, you couldn't see my face. So I'm not sure how good of a focus that is, and I am thinking about getting a motor for the focuser so it can auto focus, which is a neat little trick, but I haven't done that. Don't know when I'm going to do that. Here, let's do suggestions. Okay, I don't see any suggestions yet, so we're going to keep looking for something interesting. I'm going to get rid of the labels, hide all labels, and we're going to look at bright NGCs, maybe something interesting, a Messier object, a blinking planetary. Ooh, we got the North American nebula, but it is low, low, low in the sky. Same thing with the dumbbell. So these are the summer constellations that are starting to come out. Summer objects, but nothing quite yet. M92. What is M92? It is another globular. Let's see what this one looks like. Let's grab that one. 30 seconds. I'm going to do 20 seconds on that one. 800. See how close it is. There we go. So hit that. Start the capture. So M92. So let's find out a little bit about it. Hello. Select M92. I think it would track it, but it's not. 1118, 1118. Now. Yep, that's fine. More zero noise reduction. Download. Second now, there we go. So again, we have a globular, and we can resolve down to the core. I think, yeah, focus is slightly better, but not too much. And again, if I do a longer exposure, I'm just going to do a 30-second exposure, same ISO, because I want you to see the difference between it. We'll be able to actually go deeper down into the core. We'll be able to see more detail down in the middle. Short exposures, you pick out the brightest stars, you pick out the brightest objects. A 15-second exposure really is not long. Typically what we'll do is for nebula, I've done 20-minute exposures before with special cameras, and when everything is set up properly and everything is tracking the right way, a 20-minute exposure is completely doable. Usually we try to do less. One of the issues we have with long exposures is, well, we have satellites, and if a satellite passes right through your field of view, it looks like a long streak. Now, after midnight, that's not really much of a problem. Midnight to 3 a.m., it's not a huge problem because we don't typically have a lot of satellites which are that high, and those that are that high up, they're far enough away that they're fairly dim. You don't really see them. But after astronomical twilight, let's say call it 10:30, 10:30 to midnight or so, and then before the sunrise again, the satellites that are passing overhead are being lit up by the sun, so they are visible to various degrees. All right, this one's coming in. Did it come in? Yeah, that was it. Okay, so you can see we got a little bit deeper into the core. We got a little bit of streak on the stars. It's not perfectly focused, and it's skewed a little bit. It's moving. Yeah, it's moving, and you can see that over 30 seconds that it did move somewhat. But we can see deeper into the core. We see more stars out here that we really couldn't see before. Let's say, like here's an example. I can barely see something on my screen. 1, 2, 3. But we jump out, we get a longer exposure. 1, 2, 3. They really pop out. So the longer exposure, the better it's going to be. I'm going to try to do this. So we're going to reconnect. 0.5 seconds. I do not want a 0.5 seconds. I want to do 1.5. There we go. 1.5. So here we go. We got this thing, and I'm going to try to find some nebula. I'm going to find a nebula first. I'm going to go away from that guy. What is neat? Hercules, Spindle Galaxy, M101. Maybe we can do Pinwheel World. Maybe Whirlpool. Let's see what the spindle is like. Oh, maybe we can do the spindle. Okay, let's try this. Let's lead to this location. Yeah. Okay, so we're close. Deselect, try select. Why don't you want to center it? Center. There we go. Let's just keep it centered right there. Now over here, it's, who knows where, it's somewhere over here. So it's picking this up good. I'm going to do this. Begin guiding. So what I'm doing now, hopefully. Oh no, no. It's stupid. There's a spindle right there. I believe that's it right there. We're close to it. Is it guiding? I don't think so. I think it's being stupid. So let's de-stupefy it. Clear calibration. Loop it again. I believe that's a spindle. We'll find out. So this is a little application that's called PhD. It stands for Push Here Dummy. And it is a auto-guiding application. I see blinking planetary. Someone's asking about blinking planetary. Saturn is not up yet. We're going to have to wait until after midnight. 1 a.m. should be nice, so we'll see how that goes. So where was it? Oh yeah, Push Here Dummy. So this is a nifty little application. And what it's doing is, right now, it's learning how the mount works. So I pick a star using the guide scope. The guide scope then the program sends a signal to the guide's camera, telling the guide camera to tell the mount, go west a couple steps, then it's go east a couple steps, then north, then south, and now it knows how to move. So what's it doing? It's going west. It's moving it very slowly west. So 37 steps. It has not moved very far, which is fine. But it's figuring out how far it has to move and in what direction. So now, once it's actually trained, once it knows how far it needs to go, it will work to keep the guide star right there on 1 pixel on the camera sensor. And if it moves over just slightly, it'll push it back. If it moves over in this direction too much, it will push it back in the other direction. Hence, Push Here Dummy. But it is... that would be a dog. It did not move enough. So something's not right. Oh, I know why. We have to come here. We have to deselect. Let's just do deselect it. Yeah. Let it do its thing. Now come back here and retrain. Yeah, I think, oh yeah, it's moving better now. Okay, so now it will know how far to move it. Yep, 8 steps, so that's fine. Hope so. Try it again. Alright, we'll see how well this does. If not, we'll just go ahead and take a... we'll just take a picture anyway. 30 seconds. Let's see what it does. I mean, what's the worst thing that'll happen? It'll look bad, right? And I don't think... I'm going to go ahead and check my other computer and see what this one looks like. Where is view planet? No, labels planet. It's moons. Yeah, I do not see I do not see Jupiter up yet in the east. In the east. No, not yet. So maybe if I go a couple of... that's not right, no wonder. Yeah. Nope, it is not up yet. So it will have to be in a bit. 11? What? Seriously? Okay, so I've got Jupiter and Saturn just over the horizon. Probably. Maybe. Yeah, maybe just over the horizon. Where do we gotta look? Nope, I don't see them. Not yet. So it's probably in the clouds. So we're not going to be seeing those. All right, what am I looking at now? Oh, here we go. There we go. Now I got a galaxy. There it is. That is the Spindle Galaxy. 30 seconds is not much of an exposure. Just do a 60-second. Let's see what Push Your Dummy's done. Cool, it's guiding. All right. Let's clear this out. Probably not guiding terribly well. It's fine. Let's do a 60-second exposure. 800. That's fine. So it's called the Spindle Galaxy because it is a spiral galaxy. We are looking at it edge on. And all of a sudden the wind picked up just a tad. And it's getting a little bit chilly. Huh. Alright, I should probably get dressed then. Speaking of getting chilly, so something that's really interesting that you can do. It works well on a hot summer day, not so much in the winter. But space is cold, and you can detect it with your hand. And the way you do it is you just literally put your hand up like this, see, towards space, and you can feel it's colder than if you turn it around like this, pointed at the ground. So here you're actually detecting the heat coming off the ground. This, you're not. You're detecting, or you're losing heat basically to space. Now, on a cloudy day, if you do it, it won't feel that cold. But on a night like this, oh yeah, you definitely feel it. And it has to be at night because during the day, well, the sun's going to be warming up your hand. Sounds effective. You can also take a laser thermometer. So if you have one of those nifty little infrared thermometers with the laser on it, it looks like a little gun. If you point it up in the sky, even during the day, it will show, it can be anywhere like from 20 degrees to negative 14 degrees. Then if you point it up at night, it'll be even colder, negative 40, negative 70 degrees. So it is specifically, or especially cold up in the upper atmosphere, and that's what you're detecting. And now I have, what is that? Some type of a grasshopper, something. Go away. So here we go. 9 seconds noise reduction. So if you give me a moment, I'm gonna go put something on because it is getting chilly. And where is my light? There it is. Let's see what this looks like. There we go. That's not too bad. So we have the Spindle Galaxy, and it is colored red because of our filter. So this is a camera specifically for nebula. But what we're looking at is a galaxy, and what's neat is I couldn't see this galaxy very well at all from Burleson. We can see it down here from Grandview pretty well. So what we're looking at is an edge-on spiral. This is the center of the spiral. Spiral arms going this way and that way. And this dark band in the middle is dust. It is just a dust band, that's what we call it. So that dust is blocking our view of the center. And this is also one of the issues why we can't really see, visually at least, the center of our galaxy, because we have a lot of dust that blocks it out from our field of view. Ooh, oh, that's much better. You know, it's Texas, it's May. You wouldn't think it would get this chilly. I think it's getting ready for the summer, but really, it's actually kind of chilly. It's down in the 60s, I think, right now. So, yeah. Pants. Good thing I brought pants too. Because as warm as it was during the day, right now, yeah, it's getting a little bit chilly. Now, the only thing I'm worried about now is if I take off my shoes and put on my pants, how quickly will scorpions get inside? And I don't know the answer to that. I'm gonna do a 90-second exposure and see what we can get with that. But that is neat. So we're picking up stars, we're doing some decent guiding, and we picked up a galaxy. Let's see if we can find another galaxy. Let's take one more image. I want to see just how long we can get it. There's a spindle. What else is nearby? So we got the spindle. We have Bode's Nebula, M81. Of course, there's always M81. You know what? Let's just start picking up galaxies. Let's start picking up the pinwheel. So here's the pinwheel. Let's see what we can do with the pinwheel. Remember, something that's interesting with some of these galaxies, the whirlpool, not the whirlpool, Triangulum is fairly big. Cat's Eye Galaxy. Yeah, we'll do M81 too. Black Eye Galaxy. There's so many around here. You know what? Let's do that. Let's just start picking out galaxies. Take an image of a galaxy, go on to the next one. Take an image of the galaxy, go on to the next one. So we have a little bit more time on this one. I'm going to warm up just a tad. Whew. Hopefully I don't fall over. Okay, someone's asking, why do I take raw photos? Raw photos have a whole lot more detail than a JPEG. If I just take JPEGs, then I'm really limited to the amount of data that's in the image. Raw is all the data for the image. I want as much data as I can, because then when I go into Photoshop and I start manipulating it, or any other application, I now have a lot of data I can work with. So just because you see with your eye black doesn't mean that it's all the same color of black. And in fact, it can have a whole lot of levels that you aren't necessarily privileged to. For example, let's see if I can do this. There we go. So now I'm able to see more stuff out here, over here, and over here than I could before, just by manipulating my histogram here. I'm able to pick out more details all through this object. And all I'm doing is manipulating my levels. Come back here. And if I reset this, where's my reset? So what am I? Did that. Just by manipulating the histogram. And I could do this in Photoshop much, much better. But the problem is I don't have Photoshop on this laptop. I should probably install it on here. I have it on the other machine, but not on this one. So next Star Party, hopefully we'll be able to mess with that. Reset. There we go. So now we're back to what it was. So again, this is the raw image. You see some detail, but just by manipulating the histogram, just by playing around, I can see that there's a lot more, that the galaxy extends out further. Stuff like that. So here we go. Downloading. Let's reset this. Let's do RGB. Ah, no, we got some streaking. We got some streaking. What happened, PhD? It just moved off. Didn't center. Alright, fine. Nuts to you, PhD. Alright, So let's go pinwheel. Salute M101 pinwheel. I'm going to turn this back on. But it's kind of neat. 1.5 second exposure, we could already see a galaxy just in the guide cam. Alright. Here we are. So what are we at right now? What time is it? 11:37. That's not too bad. Ring Nebula is a bit low. So along with Saturn, Bode's Nebula M81, we'll see what that's like. We'll go ahead and try with the ring in just a bit. Here. Yes, yes, yes. Uh-oh. Alright. Try that one. It's going to recalibrate. Alright. Should have a galaxy here somewhere. Let's go ahead and take a... Oops. Take a quick exposure. Be able to see something in 20 seconds. Good. 20 seconds, let's see what happens. And this anti-vibration, that is a delay that I put in specifically because in the DSLR there's a little flip mirror and it pops up, and when it does, the whole thing shakes. So what we want to do is let it pop up, wait 2 seconds for the shakes to go away, then take the exposure. And then when it's done, it just drops back down. A couple more seconds on that. That's not too bad. Okay. Yep, I don't see anything on the other star chart here. All right. Let's see. What do we got coming down? What do we got coming down? Nothing. Something is there, I don't see it. There it is. That's a galaxy. That's pretty faint though, isn't it? The 20 seconds. I gotta bump that up. We gotta do a minute. Let's see what PhD is doing. PhD is not liking it. It is not liking it at all. Oy. I don't think it is happy with this camera. Okay. Alright. I should stop it. Maybe I should do this. Mount. Camera. Connect. Yep, it's not letting me do it. Yeah. Alright, that's fine. It's in the field of view. Do 60 seconds, see what happens with 60. So we know it is there. It is that fuzzy bit. Stars appear as rough points of light. This thing is just fuzzy, diffuse. And there's something, it looks like there's some spiral something going around. Something ring-shaped that's going around that. It's hard for, well, I can see it on my monitor. Let's see if I can boost this up. Yeah, there's something there. Can't tell you what it is exactly, but it looks different than the stuff around it. So, we'll see. There's a whole lot of noise, but there's just something about this area that looks different, where we can compare it to any other region nearby, and this just has more to it. So, in the center there, that bright spot just doesn't appear the same as any other star around here. So, there's a difference. That's our galaxy. So we have something in there. I'm just hoping. I don't know what's wrong with this looping. Just didn't move enough, huh? All right, let's do. While that thing's going, I'm going to clear calibration. Should be fine. Oh, where was it? Trying to remember where this is. It's been a while since I had to mess with this. View. I don't need a server. Now I think we have coyotes. Yeah, those are coyotes. And the dogs are answering them. Alright, there is something on here that I'm missing, and I can't remember where it is. There we go, camera setting. It's fine, calibration. Yeah, I believe that's right. Yep, the rest of it was fine. What do we got? What do we got? Okay. Reset this thing. And we can just barely make that out, so let's bring it back up. Okay, we have some spiral arms. Can you all see that? I can see that. Oop, too much. We got some spiral arms right there. They're faint, but definitely there. There's one here, there's one here, there's one here. Yeah, there's one going out here. Something this way. So this is fairly large. Yeah, I could... this really needs a longer exposure. I'm going to do 60 seconds at 1600. It's going to introduce a whole lot of noise to it. Yeah, it'll be noisier. Let's see just how noisy it is for color. See, this isn't too bad. This is not too bad for color. Switching to L is luminosity. It's black and white. It makes it easier to see some of the stuff. So let's do this. Let's do 90 seconds at 1600. It'll be noisier, but I just want to see if we can pick out any more detail out of it. The guiding looks... so we're not going to bother with guiding, I guess. We'll see what we do with 90 seconds. If it's too much, if there's too much streaking, we'll just knock it back down. But I kind of want to see what it has. Something to think about when you're doing astrophotography. So Joe's asking, does PhD work through the guide port? Yeah, it's supposed to. It did last time. Don't know why it's not doing it now. I may switch to a different camera and see if the other camera works better. Okay, so raw images, actually any astrophotography images, typically they are going to look like this. That's it. It's going to be dark. You're not going to get big bright images right away. You're not going to see huge nebula unless you're taking a picture of the Orion Nebula, and that's really about it. Everything else is going to be dim, sometimes barely visible, and everything that we do, we have to manipulate the images. We don't add data. We don't go in and clone off one section and paste it into the other, but we have to play with the data. We have to change the levels. We have to stretch the histogram. There's a whole lot of work that needs to be done just to make stuff visible. And it's not us. If you look at raw Hubble data, which you can actually do, you can actually go and download raw data from Hubble that is, a year, 2 years, 3 years or more old. And you can take that data and you can play with it. You can bring it into your image manipulation program, Photoshop, PixInsight is a specific one for astronomy, astronomical images. You can take that, you can take the Hubble data, and you can create your own images out of it. And when you look at the Hubble data, you'll notice it is dim, it is flat. To our eyes, it appears really flat. You don't see a whole lot of detail in there just on the raw images. It's just this hazy gray for the most part. And you'll see that it's separated out. So Hubble uses a number of filters in front of its cameras for the hydrogen alpha light that we talked about, sulfur 2 light, which is also a deep red, and oxygen, which is like a blue-green, oxygen 3. So it also has a bunch of other filters, but those are the three primaries. So a Hubble image, like the pillars of creation, for example, if you look at them, you see them in full color. In reality, they don't look anything like that. They're very, very dim. To our eyes, they'd be gray. Basically, for any any of the nebula, you could be a couple hundred light years from it. You could be almost within it. And your eyes, to your eyes, just looking around, it would look gray. You would not really see any color. Same thing with the Milky Way. If you were just outside the Milky Way and you were looking at it, it would look pretty gray. You wouldn't see bright colors. You just wouldn't see a whole lot. See what that does. No, I don't want that. Building. Do this. There we go. Now I got some decent contrast. Yeah, okay. Here we go. Take a look at that. This is what dark skies get you. Minimum of trailing of the stars. It's not too bad for 90 seconds. So we have spiral arm that goes this way, spiral arm that goes that way, spiral arm that goes this way. It actually extends way out here. So galaxy isn't just this core. All we could see at the beginning was just the core and nothing else. And by just taking a longer exposure, going to 90 seconds and also bumping up the ISO to get more noise, we're not able to make out the arms here on the galaxy. Is that cool or what? I think it's pretty cool. So this is what, the pinwheel? What are we looking at? Pinwheel galaxy. That's what we're looking at. All right, so let's jump on to something else. What's next? Whirlpool galaxy. And all these spirals look alike, right? Whirlpool's neat because it actually has a second galaxy that it is sucking material off of. Let's go ahead and slew to the whirlpool close by. So in here, any minute, this is a Hubble image. Now I need coffee. So this is a Hubble image. This is a elliptical galaxy that's close by. See some material here, and it is sucking off material from here, just the gravity of this one. So we see a lot of dust lanes through here. We see, let's go center. So we see dust lanes all through here. We see these red areas. These are actually, let's see, go ahead, 90 seconds, let's do that. Street capture. So what we're seeing through here, we see a lot of dust, and again, this is a Hubble image. A lot of dust, light from stars. The red areas, these were taken in hydrogen alpha light, and these reveal places of basically star birth. This is, these are nebula, these are gas clouds full of young, hot, bright stars that are exciting the hydrogen in here and making it glow red. And we know that those are star birth areas because these young, hot, bright stars, one, they don't live very long. The bigger the star, the quicker it dies. So they're big, live fast, die young kind of thing, burn the candle at both ends. They give off a whole lot of light. They're very, very hot. They're white, they're blue-white. They give off a lot of infrared radiation, and they're lighting up these clouds. Okay. See, 11:51, huh? Okay. So when they're doing that, the Hubble telescope was able to put that hydrogen alpha filter in there, get this red light, and then add that to the image. So again, this is a totally false color image. But it's fine because we learn about stuff by looking at false color images. For example, like the pillars of creation or any other nebula. If you looked at that if you took hydrogen alpha image and you took a sulfur 2 image and you took an oxygen 3 image, you'd see a whole lot of red and a little bit of blue-green. And that's it. You really wouldn't see anything else. So the Hubble images use what's called the Hubble palette, or SHO. And what that means is sulfur 2, you make that red. That is your red frame, your red layer on your image. Hydrogen, you turn that into green. So even though it's red, you just shift it and say, okay, this data really means green. Oxygen, which is blue-green, you take that light and you say, okay, this data, even though it's blue-green color, we're just going to say it's blue. Now you have a red, green, and a blue, RGB, you combine them together, and now you have a full color image. It is a complete false color image, but that's okay, because now we can look at the image and we can say, all right, anything that's red in that image, we know this is sulfur. Anything that's green in this image, we know that is going to be hydrogen. And anything blue in the image, we know that's oxygen. And that becomes much, much easier to figure out than trying to differentiate two very close colors of red. Ooh, oh, that is cool. That is cool. That is really, really nice. Let's look at that. So again, I'm going to reset this thing to RGB. This is the raw image, which is still actually pretty decent. That's not too bad. We can see the spiral arms really, really well. We can see that there is a connection between this galaxy and this one. There's a little bit of trailing on the stars. Yeah. It is what it is. So I'm not going to worry too much about it. But we can actually see spiral arms really, really well. So if I get this back, do this. That's not what I want, but that's okay. I want to get like some decent contrast so we can see them pretty well. This is blowing out the core. I don't necessarily want to blow out the core, but what I'm going to do is bring the rings up. So that's not bad. It's not bad at all. So we can't really see the dust lanes. And again, this is one image. And typically when we do astrophotography, we will take image after image after image after image. It is not uncommon to have 5-minute exposures or even 10-minute exposures and add them up to having 7, 8, 10 hours of data for a particular image. And what that means is you're not shooting all one night, you're shooting over multiple nights. And this one, it's typically done, it's nothing unusual. There's applications which will go ahead and control your telescope for however many hours, pretty much all night. So there's Sequence Generator Pro, which I actually have, and I haven't had time to play with it and get it working. I need to eventually do that, but just like everything else, it's a lack of time. Sequence Generator Pro will actually connect to your mount, align your mount, It will use PhD to go ahead and do auto guiding on an object. It will slew to your target at a particular time. Um, it will start the auto guiding process. It will go ahead and take all the exposures you want. Once it is done with that object, it will slew to your second object, reinitiate guiding on a star there. It will go ahead and then again take all the images that you want. And it will just keep doing that over and over and over again until the night is done. And you can come back the next day and say, hey, do it again on the same object, do it on a different object. It is all doable. Here we go. Sunflower Galaxy. That looks pretty neat. Let's see what we can get with that. Slew to that location. But that's not too bad. For one image, even with a little bit of trailing, that is not bad. We're able to see a dust band right there. We're able to see the spiral arms. We're able to see both centers of both objects. That is not too bad at all. So the skies here are fairly dark. It's not super dark. If you've ever been to Big Bend, that is super dark. But this is fine. This is actually fine. Anything? There we go. Now it's centered. Let's go ahead and take the next image. Again, we're going to do 90-second exposure and see what happens with this galaxy. Here we go. Now we're open. I don't know if y'all can hear that click sound. There's two clicks. There's one, which is the shutter opening, and then there's a second quieter click 2 seconds later. And it's nice. Yeah, this is pretty neat. This is nice. It's a little bit chilly. The moon's out. It's kind of bright. But it's not bad at all. It's significantly quieter than Burleson, I will give it that, even though there are trucks coming by. At my house, it is along the flight path for, or the landing pattern for Spinks Airport across the highway. So the small Cessnas are just a couple 100 feet overhead and they pass by. And actually, there was a Cessna here earlier about it's about 8 o'clock or so, so it wasn't sunset yet. Sun was still out, and I was trying to get set up, and I was getting the telescope mount set up. So I had all the stuff on it. I had just loaded the telescopes onto it, and I was messing around and heard the airplane. So I looked up, and the guy was actually banking around us. He was taking a look at what I was doing through his side window and turned through about just over 90 degrees. And then once he was nearly overhead, he leveled off and flew off in a different direction and then I think he turned back to his original flight path. But he veered out of his way to see what was going on. So I found that a bit funny. All right, minute left on the noise reduction. So we're going to be looking at the Sunflower Galaxy. Let's go back to it, get a preview of what it possibly looks like. So what we should see, what we should be seeing is a bright core. Should be seeing some stars and probably a dust band or two. We should definitely see this dust band right there. This one closer to the center, maybe not. I don't know. We'll find out. But the whirlpool came out pretty nice. I'm happy with that one. Now, I'm not happy with it as a final image. I would definitely not take this image and enter it into a contest, because this just looks bad for that. But for just a quick shot, just for taking a look at data, just to see the structure, just to see this galaxy, yeah, this isn't too bad at all. And I will say, even in a dark sky site, you will not see this kind of detail through a telescope with your own eyes, because your eyes just aren't sensitive enough. The camera is gathering photons over a period of 90 seconds. Your eyeballs don't do that. Your eyeballs grab everything at once. Here's a sunflower, so we're seeing right there that dust band, and that's really about it. So I went ahead and I kept the same histogram as we had before so we could pick out some details. But this is fairly, yeah, this isn't too bad, but we are actually seeing a galaxy. Now, that may be something else too. Star, I can't tell if that's star or what. But that's fine. I'm just looking around to see if there's anything else to see. So what's neat is, if you remember the picture of the moon took up space about this big. So this, let's go back to here. So if the moon is this big, these are taking up a significant portion of the sky. In fact, if we look at Triangulum, the Triangulum galaxy, that is, I think it's as big or slightly bigger than the full moon. So, but it's such a low surface brightness that it's just really hard to see. Look at the cat's eye. Let's look at a cat's eye galaxy real fast. I don't know if we'll be able to see much, but I think we'll skip over the cat's eye. I don't think that's terribly interesting. M106. What is M106? A really, really faint one. I'm not really interested in really faint ones right now. Black Eye Galaxy. I think I'm going to go with M81. Black Eye. I don't know how we're going to pick this one out. It's also fairly close to the moon. Oh, we got a ton over here. This is Markarian's chain. Yeah, we got Markarian's chain over here. But the moon is pretty close to it, so it may wash out some of it. It's hard to see. We got a bunch of galaxies in here, but I want to try M81. Someone suggested that, so too many. M81. Bode's Galaxy. Where are we looking? Bode's Galaxy, okay. Yeah, you know what? Let's just go to Bode's Galaxy. Just slew to that. We'll just go way back over. Alright, anyone else have any questions, comments, concerns, annoyances? There's about a 30-second delay between what I have as live and what YouTube is actually sending out. So yeah, there's a tad bit of delay. Let's see. I'm gonna go look at the horizon. I spy with my little eye something beginning with J. And that would be Jupiter. Except for the fact that Jupiter is really low on the horizon right now. In fact, it looks red. And if you were just looking at it, you would think that it was Mars. It is not. It's Jupiter. But it's just barely over the horizon. And Saturn is not too far behind it, but it is still, yeah, it's not visible from here. So it's, I can't tell if it's the horizon or the tree line. But in any case, so we're going to look at Bode's Galaxy. There we go. No, that's not it. Starting that. So we're going to go Bode's Galaxy. So these are actually two galaxies. There's M81 and M82, and they're close together. So we're going to see them together. Hopefully. Probably. I mean, gotten pretty close now. We'll jump onto a Markarian's chain and just get a ton of galaxies in the same image. Am I taking all of my equipment down right now or leaving? Oh no. Oh, you've got to be kidding me. Oh, you've got to be kidding me. Oh. Oh, you've got to be kidding me. You've got to be kidding me. Okay. Elasticsearch load, prod find chips. Okay. Sorry. I'm kind of on call right now. So, yeah. Um, hmm. I gotta go wake somebody up then, because this is something else that. So, I work as an internet engineer, and I am on call right now. But um, yeah, there's a bit of a problem, and unfortunately, uh, I gotta get someone else to look at it. It's because this is actually something that I don't work with at all. Um, so I'm gonna get someone else to do it. 70 seconds on noise reduction. Sorry about that. I had really hoped that be all clear for tonight. Nothing would interrupt me, but well. So I'm asking someone else to take a look at it, see what it is. But it is something that I typically don't look at. It's not my wheelhouse. I am not the subject matter expert on it, and therefore, um, part of the on-call duty is to find the person who does know how to do it and get them to take a look. I know who deals with it. Now I'm asking him. Worst case, if he doesn't answer in a couple more minute or two, I will call him up and wake him up because it's just after midnight. Don't feel too bad for him. He would do the exact same thing for me. So Joe's asking, will I be taking all my equipment down tonight or leaving it set up? A significant portion of my equipment will go down. Probably all of it. I got to fit it back into my car. It's a nice game of Tetris. I don't think I'll be leaving anything because tomorrow I have a whole lot of stuff I got to do around the house, and I didn't plan on driving back down in here, back down to Grandview to pick it all up again. So why are we seeing this brightness around here? Well, what do we point it at? No, point towards north. Oh, we got clouds. That'll do. It's a little bit of haze from clouds. Hit RGB and reset this thing. There we go. Now we can see Bode's galaxy. We have a little bit of trailing, which is fine. But all we're picking up is Bode's galaxy here, not picking up the cigar galaxy next to it. I don't see it. Bode's galaxy right there. Cigar galaxy right over here. Come on. So what are we looking at? Bode's galaxy. Cigar should be close by, but I do not see it. I just don't see it. And I think it should be over here somewhere, or it's off somewhere. It is not, oops, it is not close by. Okay, but we got M81. We've got M81. So I'm going to see now. So what was that? Fan stars. I want to do not sync on it. Info, show info. Position in the sky. Let's see, what is its magnitude? Ooh. 1.6 AU. It's not that far from the Earth. But what's its magnitude? Come on. Other data. Paramag. Oh, never mind. Look at that. 8.28. That's gonna be dim. I'm not gonna worry about that one. There's no tail on it. It's a little bitty dim thing. Owl Nebula, maybe. Ooh. Here's another galaxy, but this is almost an edge on. Let's find something more interesting. I want to go to Markarian's chain. Even though it's near the moon. Oh, wait, let's do Sombrero. Southern Pinwheel. You can do a whole lot. Wait, what's up north? What's up north? Beehive? No, roads. Sunflower, the Whirlpool. So we saw the Whirlpool. Did we? Yes, we saw the Whirlpool. Did we do the Pinwheel? We did the Pinwheel. Black Eye. We don't need to do Black Eye, I don't think. M53. Another galaxy. No, it's another globular. We've seen a globular. I want to get to Markarian's chain down here. The Markarian's chain is just a bunch of galaxies all through here. And oh, here we go. Let's grab this right there. Let's look at this location. So these are actually elliptical galaxies. We got a little edge-on spiral there. We got another edge-on spiral there probably too. Virgo. I think Virgo is one of the largest galaxies in our area. It's just gigantic. We have so many here. A lot of spirals, a lot of ellipticals. Yeah, here we go. Okay. Let's see what this will do. Start picking stuff out here. Here, another 90% exposure. So in terms of galactic evolution, it looks like, from what we can tell, you know what? First, I'm going to call him. Yeah. I'm going to wake him up because he's not answering. Oh, no. Okay. I'm going to call somebody else. He's not answering. Oh. You've got to be kidding me. You've got to be kidding me. Seriously? Okay. All right. Galactic evolution. Where was I? Okay. See how far this has gone. So galactic evolution. What it looks like is we typically have small galaxies start off as irregulars. They grow to be bigger and become spirals. Spirals, you can think of as almost a middle-aged galaxy. The spirals last for a long time. But when two spirals combine, when basically one cannibalizes another one, or two of similar size come together, they throw off stars. The spiral arms are just torn apart, and eventually the multiple galaxies, the two galaxies or more, settle down into one large elliptical galaxy. And the stars are typically old. There's no new or very little new star formation in those galaxies. All the gas has been torn apart and spread out roughly evenly, and they'll eventually just die. The stars will die, and the galaxy will grow dim. Spirals are the ones where stars are typically being formed. Ellipticals seem like they're the remnants of galactic collisions. Not getting any answers yet. All right, let's see what happens. He's not answering. Who else? Nope. I have to go find somebody else. Oh, that is so overexposed. All right, that's a cloud there. Let's drop that down to 50 seconds then. See, I'm not even... We have a galaxy here. Where else? Up on top, we have another galaxy there. But again, it's just too overexposed. It's just... I can't even use that. The previous one was better exposed right there. This one's just way too much. Camera's cold, relatively. Well, it's 25 degrees. But yeah, it's just too much. So, all right, 12:17. That's not too bad. Let's look at the map here. I think one of the issues is it's so close to the moon. It is. It's just so close to the moon. I think we're just getting, and there's a little bit of haziness in there. Yeah. So I think what we're picking up is moonlight off of the clouds. Yeah. I don't think it's going to get any better. You have to get away from the moon. Oh. 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 Now we're talking. All right, so we got the Eagle Nebula, where the pillars of creation are. I'd say let's go for that. So now we're looking at the Milky Way. And north towards the south. Okay, someone just answered me. All right. That's still going. I gotta call somebody here for this thing, so. Velcro is releasing. Velcro fell. Yeah. All right. Getting there. It's getting there. It's getting there. So, the Sagittarius star cluster. This is a galaxy that's been cannibalized by the Milky Way. Neat. All right, let's do this. 50-second, 60-second exposure. Go from there. Meantime. All right, well, that's fun. No one's answering. Try this again. Ugh. Okay. 35 seconds. All right, that's going. Not too bad. Not too bad. All right, hopefully we'll be able to get something. So this is the Eagle Nebula, the Pillars of Creation. Is that what we're doing? That's what we're doing. That's not a very good image. So it's called the Eagle Nebula because it hopefully kind of looks like an eagle. Black Swan cluster, and it looks Sagittarius. That's neat, but I want to pick up down here the Lagoon Nebula and see what that looks like. Come on, come on. There we go. All right, for 60 seconds, not too bad. It's not too bad at all. We got a little bit of trailing, but that's fine. This right here is the eagle. It's got the wings going out. Let's see if we can get this in. There we go. These are the pillars of creation from the Hubble image. And it kind of looks like an eagle. There's the head and the arms, kind of, sort of ish. So people thought it kind of looked like with wings going out this way and that way, but those are the pillars of creation. And the interesting thing is, it's a temporary structure. So and at the distance that it is right now, 10,000 something light years away, because it's close to the center, it probably doesn't even exist anymore. It's probably been broken apart. So it's not too bad. We can do a longer exposure, pull out a little bit more detail, but I think that's fine on that. Let's jump down to the lagoon and the Trifid. Let's do, center right there. Drop back down. There's not much to see in the Sagittarius star cloud. It's a bunch of stars. That's really it. Hello? Anything? Didn't go. All right, let's try that again. Slew down to here. There we go. So it always overshoots and it comes back up. Any other questions? Any other objects you want to see? Another 60-second exposure. Go from there. Okay, sorry about that. I gotta keep seeing. Okay. My wife is asking me to please come home. So we'll stop this fairly quickly. So what we're looking at right here is the Trifid off in the corner. I think we got to recenter this. Slew to that location. Take another image of the Trifid just so we can see what's going on, what it looks like. And then we'll do the lagoon, and I think that'll be enough for the night. I think we'll finish it up in a few more minutes, and we've been at this for a while. And I have a support call I have to keep trying to get somebody onto, but geez. What would happen if I did a 3-minute exposure? I would get a whole lot more data. It would look a whole lot better. But I'm not doing tracking very well. Ooh. So I would just get more data. And again, if I reset it, this is the raw image. I would see more contrast. That would be it. Now, what's neat is, if we zoom in, I want to bump this up just a tad. Oops. Again, playing with the contrast here. We're looking at the Milky Way. So thousands, easily 1,000 stars in the field of view right here. Easily. And we're just looking deep in the Milky Way towards the center of the galaxy. So I got to keep calling and seeing if someone answers, hopefully. But 10 more seconds, and then we'll do a 60-second noise reduction, and hopefully the Trifid will look nice and pretty in there. And we can also do an RGB to see what the... there we go. So the red part right there is excited hydrogen. Yeah, not getting anybody. Hopefully it'll be somebody else. Nope. Again, no luck with anybody right now. Okay. So all I can do is snooze it. Now, yeah. So it's important, but it's not apparently critical. Well, it is critical. Somebody. Okay, here we go. So here's the Trifid. That's not too bad. So if I brought this into Photoshop, we could actually maneuver or play with the colors a little bit more. But you can see the dust bands through here. Called the Trifid because it looks like it's in 3 parts, like a tulip, I guess, or something. So we have the blue part over here. So the blue part is where you have more oxygen. The red part is where you have more hydrogen. So if we switch it to the luminosity, just black and white, you can see some more detail. Again, we have a little bit of streaking because, well, I didn't bother. But this is a raw image. That's all that it is, just a raw image. And in the raw image, we can still make out color. But again, remember, this is a 60-second exposure. If you're looking at this with the naked eye, you're not going to be seeing it terribly well. It will look gray. It always looks gray. So here's the lagoon. We're going to slew over to the lagoon. And there's so many clusters here because we're looking into the center of the galaxy. And this is Sagittarius, so we have a globular here, a globular going through the center of the galaxy. That's actually kind of neat. So let's take next one, start capture, another 60-second exposure. So the Lagoon Nebula is definitely a region of star formation. This is well overexposed, but we have a number of little oh, there it is. Cool. Yeah, got it right there. No, this is the Trifid. Lagoon is down in here. Yeah, we're able to see some nebulosity just with this camera in just a second and a half. of exposure. 3 seconds. Let's see what 3 seconds looks like. Oh, we got a whole lot more. No, this is the lagoon. Sorry, this is the lagoon. So 3 seconds of exposure with this camera. And we can see quite a bit. 6 seconds. Let's see what 6 seconds looks like. Oh, wow. Yeah. So it's a whole lot of nebulosity. We have some places where we don't see any stars. We see this dark band right through here, just all through there. So this is a dust lane. This is just dust. So it will go ahead and actually block the light that's behind it. Now, one of the cool things is that if you have an infrared telescope, like Spitzer, it's an infrared telescope in orbit, what you can actually do is see through the dust and see stars on the other side. If anyone picks up on this line, doing some noise reduction. Still going. Sorry. Okay, so that's not bad. That's actually pretty. I like that one. Let's look and see if there's any star trailing. There's slight star trailing. There's so much noise in here, though. There's a lot of color noise, but look at that. This is what an astronomical camera lets you do. You can, you see a lot more of this red. You see a lot more of the nebulosity. It really comes out. Actually, in the video over here, it's going out. It looks really, really deep red. That's actually kind of cool. On the laptop monitor, it does not look this red. But now we can really see these dust bands. We see more detail through here. There's a dust band here. There's one here. There's more dust all through here. So compare this image with this image. And the gain on here is just shot through the roof. This is noisy as well. I can't really zoom in on it. That's fine. I'm not really concerned. But you can see some of the details here. You can see a lot more detail through here. You can see the star cluster here. You can see the brightness that this star here is just lighting up the nebula just all through. If I want to, I can play around this a bit. I can blow it way out. You can see just how far it extends. You can see some of these tendrils. And again, this is just horribly, horribly overdone. But the raw image, just the raw image, is really super nice. And if I switch it to the luminosity, the black and white, you see some detail that's kind of hidden away because it's in the color. You can see here where there's no stars, that's probably a dust band going through here as well, because out here we see a whole lot of stars. Let's go back to Starry Night Pro. This doesn't have that great of an image on here. That's okay. We're seeing quite a bit through here. I'm actually pretty happy with this. If I drop it down to 800 and I do a 90-second exposure, I'm going to find a lot less noise. Hopefully it'll look really, really nice. Let's just play with it a little bit more. But yeah, that's really nice. I'm pretty happy with that. So yeah, we could do a longer exposure. Now, in terms of exposures, what I had done previously was 60-second at 3200 ISO. ISO in the old ASA ratings for film It was how fast was the film. The lower the number, the faster the speed of the film. And what that meant is it became sorry. Lower the number, the slower the film, the higher the number, the faster the film. The faster the film, the more sensitive it was to light. But the reason why it was sensitive is because the actual silver grains in it were much, much bigger, the silver salts, the halides. So the bigger the grains were, the more sensitive they were to photons, because the photons had more places to land on it. A fine-grained film, like a ISO of 100 or less, or 50 or whatever, with those you had very, very fine grains of the of silver halides. Well, I'm talking about black and white films at least. So you could get really, really detailed images, but you needed more light or longer exposure to get those details. With digital cameras, it's a little bit different. The native ISO on them, at least with the Canons, I think it's 100, and everything else is gain. So it's like turning up the volume. You're not getting more data out of it exactly. You're just cranking up everything, including the noise. So the quick calculation is whatever your exposure is, if you have the ISO number, you have to double the exposure for the same amount of essentially data, the same brightness level of the image, but you get less noise out of it. So we increased our exposure, but we decreased our ISO, not in a 2-to-1 ratio either. So the next image should be a lot darker, but we should see a lot less noise. But that's pretty. That's pretty. If I had used a regular camera to take that picture, it would not have been anywhere near that bright, I should say, or that red. It would be red-ish. It'd be pinkish. But it definitely wouldn't be that deep red color. But it's a nice one. I gotta keep calling somebody. I keep finding somebody. See, there we go. So less noise, a lot less color noise if we compare. But we got that trailing. It's not perfect. Oops. But it's not as much as, or we don't have as much apparent data as we do with this one. So we got this one. It's a longer exposure. So it's 60-second exposure, 3200 ISO, and then we jump to a 90-second exposure, but 800 ISO. If I was going to be taking photos and stacking them for later use, I would probably with this one be doing 120-second exposures to 180-second exposures at probably, between 800 and 400 ISO, probably 800 ISO. And then I'd be using noise reduction and a whole lot of other techniques just to get more data. In terms of just making it look pretty right off the bat, that one does a pretty good job. Right there. I mean, it's not the best I could do, but it's not bad. This one, just not getting enough data. And if I try to do something like this with the histogram stretching, then I start messing with the background, and it's just, that's just not getting anywhere near what I want. And this is just overexposed. That's just too blue. The previous one had better information, but it just wasn't the best. When it came to what it looked like from everyone's point of view. All right, let's see if I can get this thing working. Here we go. Oh, not volume. I can't really zoom in on it. Well, that sucks. So this was something I was messing with yesterday. This is an image of the sun, and I was trying to get this to work, and it just did not work very well. I need to manipulate it. So we actually have a hydrogen alpha camera. Excuse me. And I was using a new mount for it and testing it out, and we could see some prominences here on the south, but this is just a raw movie. I need to go ahead and get in here and start stacking it and modifying it to make it look good. You just can't see anything on there. It's really too bad. Jeez. All right. I gotta see if someone else is answering on here. Let's see what else we can look at, though. What else is going to be good? What else is going to be good here? Hello. Maybe we can... No. I'm not able to get hold of anybody. That's not good. Let's do North America. North America, nebula. Looks kind of like North America, Mexico, Florida, and the rest. That's supposed to be the Gulf. Let's say the Pelican Nebula is right next to it over here. It's just not showing up on here. It is a fairly dim one. I actually have several really, really nice photos from the North American Nebula, or of the North American Nebula. I took in hydrogen alpha light, so it's that deep red color. Let's bump this up to 1600 and go back to 60-second. Let's see what we get out of that for the North American. It should be fairly faint. The North American Nebula, it is large. So the full moon is a half a degree. We can prove it by finding the moon. The moon is about a half a degree in size. Okay, so this is halfway. There we go. Roughly half a degree. Go back to... Oh, we have a cow who's awake. Oh, look at that. That's about 2 degrees across, isn't it? That is 4 full moons across. And yet, it is really, really hard to say. We didn't even know about this one for a long time. Why? Because the surface brightness is very faint. There's a lot of light there, but it's spread over a huge area, and we just can't see it. And it's that deep, deep red color that's really, really hard to see visually. Cool, no bugs. So this is one of those objects that we really didn't know about until we started taking photographs of the night sky. And now you can see it. So what do we got? 24 seconds left on nose reduction. It's not bad. Okay. And it is now 12:45. I've been doing this now. Oh man, it's been almost 4 hours. Some of y'all have stuck here for the whole time. How many people do we have now? We got 27 concurrents. That's not bad. It's not bad at all. But I've been sitting, hard chair. Yep, hard chair. One of my cousins actually brought me over a stool, a nice padded stool to sit on. But the problem is that as soon as I'm kind of at an angle, the ground here is tilted, so I sat down and I just rotated over. So it's not a good thing. This is the North American Nebula. Can you see something? Because I can't see anything. And that's part of the dilemma. You can be right at something and you can take a nice initial exposure and you're looking at something, I don't know what I'm looking at. Right here too. What am I looking at? Well, considering the moon was about this big, we're seeing right into the North American Nebula. We really can't even see it. It's like you can't see the forest for the trees. So we're not seeing the whole forest. We're seeing just a bunch of trees right here. And the issue is that there's a whole lot of trees, and we can't tell where, in this case, where the nebula stops. It's just all over the place. So what we need for this instead is still a narrow field of view telescope like what I have, but a wide field telescope. And ideally for the North American Nebula, you don't necessarily want a telescope. What you want is a big old telephoto lens on a camera. And you can then mount the camera and lens onto a tracking mount like this. And then you can take a photo. So something 200, 300, 400 millimeter. I think a 400 millimeter, no, let me take it back. A 200 to 300 millimeter lens will get you a really nicely framed image of the North American and the Pelican nebulas. If you don't have that, you'll have to do what I did, which is take multiple pictures. Let's see if I can get this thing. Usually I would do this in a different way. Oh man, I gotta sign in. Alright, so everyone's gonna see that. Oh well. All my pictures. That's fine. There we go. Is that what I want? Maybe. So, this is an image I took from Fredericksburg a while ago. And you can see it's big. It's pretty big. All right. Yeah. So, what we're seeing is basically this. And that's it. Or maybe this part. I don't know. We're looking somewhere in this area with that previous image. And it's not, we can't see the dark nebula in here, there. It's just stuff that's not visible. So that's not exactly what I wanted to see right now. I wanted to see, that's not really what I want to see either, sorry. No, there we go. That's what I wanted to see. Cool. So here is North American Nebula in hydrogen alpha. I got a little bit of clipping there, but that's okay. You can see some of these features. This was, I believe, a 10 or a 20-minute exposure, and I think it was about 20 images that were stacked. So it was a lot of data and then a lot of processing to remove the noise. But it wasn't a simple image like the other one, and it was a wide field image, and I had to take a bunch of them. So here, oh, there we go. This is what I wanted to do. This is what I was looking at. So this is not a single wide field image. This is a combination of a number of wide field images. I think I did a mosaic of 4 images with this. Each of those images was stacked, like I think 7 or 8 or 10 images. It's been a while. Sorry, I don't remember all the details. But again, this is North American here. This is the Pelican over here. And I had to take everything, and it's a mosaic, so I had to stitch them all together to make them all fit and then do the final processing. It's a really pretty image. But this is black and white. This is a hydrogen alpha light only, because honestly, there's not much else in the North American. Yes, you could probably do some oxygen, but there's not a whole lot. It's mostly a hydrogen nebula, but it's big, widespread, it's diffuse, and you really can't see it with the naked eye unless you have a really big telescope. And even then, you see these gray wisps. You don't see a whole lot of detail. With this, you take a large number of images and you stack them, You don't stack them to get more data out of it. You stack them to do noise reduction. You are increasing your signal to noise ratio as much as you possibly can. And then you do some more manipulation and you change your levels, and there's a lot of stuff to be done. But eventually you end up with an image like this. And again, this is such a big target that I couldn't take everything in with a single shot. I had to do a mosaic. I had to do a number of images, piece them together to get something this wide. Remember, just North America alone is 2 degrees. And for this image, this is probably closer to 4 degrees in either direction. 3.5 to 4 degrees. So the Pelican is nice. It came out pretty well, and you can see some of these details, some of these brighter areas pretty well. I think I got the clipping pretty low on it, so you can see the dark nebula through here really well. It doesn't look like it's too sharp, too cut off. Lots and lots and lots and lots of stars just all through here. It's just a really pretty image. I'm pretty happy with this one. But again, it took a while. It took a lot of images and a lot of processing and stitching together and hoping for the best. Right, I don't think I have anything else right now. It is getting late. It is nearly 1 a.m. and I still have to find somebody to please pick up my call. So yeah, it's almost 1 a.m. It's 12:53 right now by my time. I'm getting tired, and tomorrow morning my wife has informed me that I need to be up early, probably making breakfast. So it will take me probably another hour or so to pack up as quickly as I can and then head on home. So let's see, where is it? Oh. Trying to get this working. I appreciate your time. I thank you for tuning in and sticking with us for nearly 4 hours through technical issues and whatnot. But we did get to see some neat stuff, especially later on. Galaxies were pretty nice. The nebulas came out pretty nice. Everyone was. Those are always crowd pleasers when everything goes well. So if you have any questions, any comments, you can go ahead and put them into the comments on the video. And like the kids say, like and subscribe, and I will make more videos. I have a couple which are in the pipeline right now, so I'll be getting those out hopefully within the next week. And yeah, there's just always more work to do. So again, thank you everyone. I appreciate each and every one of you for tuning in, and hopefully we'll do this soon. And also, you seem to have dew coming down, so that is as good of an excuse to shut down as anything else. So thank you again, and good night.